everyone, welcome to the Data Analyst full course by Simplilearn. We live in a world overflowing with data, spreadsheets, databases, dashboards, sensors, you name it, but raw data alone doesn't create value. The magic happens when someone can analyze, interpret, and transform that data into meaningful insights that drive decisions. That's where a data analyst steps in. In this course, we will guide you through everything you need to know to become one, from mastering Excel, SQL, and Python to exploring visualization tools like Power BI and Tableau. You'll learn how to clean, model, and tell stories with data that business leaders can act on. And here's the exciting part. Data analysis is one of the fastest growing career fields in the world. Every organization, from startups to Fortune 500, is searching for professionals who can turn data into direction. So if you're ready to geek out on analytics, uncover hidden patterns, and become the decision maker's secret weapon, hit that like, subscribe, and let's dive into the Data Analyst full course together. But guys, before we begin, if you're interested in growing your career in business analytics, this course is a great way to start. The Professional Certificate in Data Analytics and Generative AI by Simplilearn is the right choice for you. This is an 8-month live online program from Purdue University Online and Microsoft. It will help you to master key in-demand skills along with exclusive hackathons and Ask Me Anything sessions by IBM. Live sessions on the latest AI trends such as Gen AI, prompt engineering, explainable AI, and many more. This program adds monumental credibility to your profile by earning certificate from Purdue and Microsoft. You'll get career support including resume help, mock interviews, and job assistance. And in just 8 months, you will master data analysis, data ethics, ETL, SQL, along with 11 plus skills. So whether you're switching careers or upskilling, this course will give you the latest data analytics with AI knowledge and practical experience to stay ahead. So hurry up and enroll now, and you can find the course link below.
In this video, we will discuss what data analytics is and the need for data analytics. Then, we will look at the different ways in which data analytics can be used, followed by the various steps involved in the data analytics process. After that, we will get an idea about the different tools used in data analytics and the companies using data analytics. Moving forward, we will see a case study on how Walmart uses data analytics for better customer service. And finally, we will perform a regression analysis in R to predict sales based on the advertising expenditure from 3 mediums: TV ads, radio ads, and newspaper advertisements. So what is data analytics? Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large datasets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has Graphics for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning. Moving on to the applications of data analytics. Data analytics is being used in almost every sector of business these days. Let's discuss a few of them. First, we have retail. Customers expect retailers to understand exactly what they need and when they need it. Data analytics helps retailers meet those demands. Retailers not only have an in-depth understanding of their customers, but they can also predict trends, recommend new products, and boost profitability. Retailers create assortments based on customer preferences, invoke the most relevant engagement strategy for each customer, optimize supply chain and retail operations at every step of the customer journey. The second application is on healthcare. Healthcare industries analyze patient data to provide life-saving diagnosis and treatment options. They also deal with healthcare plans and insurance information to drive key insights. Using analytics, they can discover new drugs and come up with new drug development methods. Advanced analytics allows healthcare companies to improve patient outcomes and experience. cancer cells and diabetic retinopathy can be discovered using medical imaging. At number 3, we have manufacturing. For manufacturers, solving problem is nothing new. They fight with difficult problems and situations on a daily basis. From complex supply chains to motion applications to labor constraints and equipment breakdowns, they deal with such problems on a regular basis. Using data analytics, manufacturing sectors can discover new cost-saving and revenue opportunities. The fourth application is related to the banking sector. Banking and financial institutions collect vast volumes of structured and unstructured data to derive analytical insights and make sound financial decisions. Using analytics, they can find out probable loan defaulters, customer churn-out rate, and detect fraudulent transactions immediately. The final application is based on logistics. Logistics companies use data analytics to develop new business models that can ease their business and improve productivity. They can optimize routes to ensure delivery reaches on time in a cost-efficient manner. They also focus on improving order processing capabilities as well as performance management. With that, now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart. With that, let's understand a case study from Walmart and how it uses data analytics to grow its business and serve its customers better. Walmart is an American multinational retail company that has over 11,500 stores in 27 countries worldwide, and it has e-commerce websites in 10 different countries. It has more than 5,900 retail units operating outside the United States with 55 banners in 26 countries with more than 7 lakh associates serving more than 100 million customers every week. It has over 2.2 million employees around the world and 1.5 million employees in the United States alone. Walmart's e-commerce branch alone employs more than 3,000 technologists from Silicon Valley to India, England and South America. More than 240 million customers shop at Walmart each week online and at its banner stores. Walmart.com sees up to 100 million unique visitors a month according to ComScore and is growing every year. Walmart collects over 2.5 petabytes of data from 1 million customers every hour. That's really huge. Now to make sense of all this information, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. Here, over 200 streams of internal and external data, including 40 petabytes of recent transactional data, can be modeled, manipulated, and visualized. Teams from any part of the business are invited to bring their problems to the analytics experts and then see a solution appear before their eyes on the nerve center's touchscreen smartboards. Walmart also constantly analyzes over 100 million keywords to know what people near each store are saying on social media to understand the customer behavior on what they like and dislike. Walmart uses modern tools and technologies to derive business insights and improve customer satisfaction. Some of these tools include Python, SAS, NoSQL databases such as Cassandra and Hadoop. Now, using all these technologies and data analysis techniques, Walmart can better manage its supply chain, optimize product assortment, personalize the shopping experience, give relevant product recommendations, and finally, optimize and analyze transportation lanes and routes for its fleet of trucks. With that, let's jump into our use case demo where we will predict the sales based on advertising expenditure using the linear regression model in R. The advertising expenditure has been made via different mediums such as radio, television, and newspaper. We will use the R programming software to implement the demo. So why R? Well, R is a free and open source software that can be downloaded from the RCRAN website. It is easy to learn and use. Our language is built specifically for performing statistical analysis, data manipulation, and data mining using packages such as Plier, dplyr, tidyr, and lubridate. R supports data visualization with the help of packages such as ggplot, Google Viz, R Color Brewer, Leaflet, and ggmap. And finally, the R software can be used in a wide range of analytical modeling including classical statistical tests, linear and nonlinear modeling, data clustering, time series analysis, and more. Now, let's have a look at our data that we will be using for this demo. Here is our advertising CSV dataset, which has 4 columns. You can see there's TV ads expenditure. The next column is for radio ads. Then we have the newspaper ads. And the last column is our target column, that is the sales. So the data set has in total 200 rows. Now, to understand the data, let me give an example. So consider the second row. So suppose you spend around $230 on TV ads, then $37.8 on radio ads, and $69.2 in newspaper ads. You can expect to sell nearly 22 units of a particular product. Similarly, if you are spending $44.5 in TV advertising, $39.3 in radio ads, and $45 in newspaper ads, you can sell around 10 units of certain item. We will analyze this data using linear regression. So linear regression is a supervised learning algorithm, which means the data has labeled columns and is used to predict numeric continuous variables. So our sales column here is the target column and it has continuous numeric variables. Now let me go to the R Studio and start with the demo. So first, I'll create a new file, then I'll select R script. The next step is to install all the necessary packages that we need for this demo. If you already have the packages installed in your R Studio, you need not do it again. You can just call these packages using the library function and pass the package names. So first, I will install the dplyr package, which is used for data manipulation. I'll be using install.packages function and I'll give the package name. So I'll type install.packages. If you hit tab, it will autocomplete. Then under quotations, I'll write dplyr. I'm not going to run this because I already have it installed in my R Studio. The next step, I'll call this package using library function. I'll give the package name dplyr. I'll run this. Then I'll install the broom package. It takes the messy output of built-in functions in R such as linear model or LM, then t-test, and turns them into a tidy data frame. So I'll copy the above code. I'll just paste it again. I'll change it to broom. Here also I'll change it to broom. I'll run this. Okay. Then I'll be installing the CA tools package, which will help us build our linear regression model. I'll paste the same code and I'll take CA tools and I'll call that using the library function. I'll run this. Now sometimes people face issues with installing this particular package. If you also face this problem, do visit the R Studio community page. Now let me show it to you. So This is the RStudio community page, and here they have the solution. You can just go through this 2 pages. Alright. After this, I will install the ggplot2 package, which is a very popular package in R for data visualization. I'm not running install.packages because I have already installed all these packages before. If you have not, so you have to run install.packages first and then call the library function. With that, let's now load the dataset. For this, I will use the read.csv function and provide the path location where my data is located, followed by the dataset name and the extension. I'll assign the loaded dataset to a variable. Let me now go ahead and show you where my dataset is located. So here is my advertising CSV dataset and this is the location. I'll copy this location. I'll move back to RStudio and let me comment this line, load the dataset. So I'll take a variable name ads and then using read.csv function, I'll pass the path location where the dataset is present. Now one thing to note is we have to change all the backslash to /, otherwise R won't accept it. And finally, I'll give the dataset name, which is advertising.csv. Let me run it. Okay, we have successfully loaded our dataset. Now let us look at how our dataset looks like using the head function. So I'll give a comment, display the head of the dataset. I'll be using the head function and I'll pass ads. Run it. So you can see the head function has displayed the first 6 rows from the advertising dataset. Let me now check the dimensions of the dataset. So I'll use the dim function. It will give you the total rows and columns present in the dataset. Give a comment, check the dimensions. I'll use the dim function and I'll pass in the ads variable. You can see it has given the number of rows, which is 200, and the total columns, which is 4. Now, if you want to get a summary of the dataset, you can use the summary function. So I'll directly type in summary and I'll give ads. Let me expand this. So actually summary function gives you information about a few statistics for each of the columns. So you can see the minimum value for each column, the maximum value for each column, the mean, the median, first quartile and the third quartile values. The first quartile or lower quartile is the value that cuts off the first 25% of the data when it is sorted in ascending order. The second quartile is the median, which has the value that cuts off the first 50%. And the third quartile or the upper quartile is the value that cuts off the first 75% of data. Moving ahead, let's do some data visualization now to visualize our data. Since our data has only numeric values, using scatter plots would be the best option. So we will visualize our sales against each of the independent variables. For that, I will use the plot function and give sales in my x-axis and the independent variable names in the y-axis. Let me now do that. So I'll give a comment, data visualization. First, I'll use the plot function, and then in x-axis using the dollar symbol I'll give sales. Then in the y-axis I'll give my independent variable. You can see R is automatically giving you the suggestions. I'll select TV. Then I'll take type is equal to, under quotes I'll give P, which stands for points, and I'll take the color as red. So you can see under plots we have our scatter plot. If I zoom in, you can see the red dots are pretty much aligned in one direction, which means if you are increasing the expenditure on TV ads, the units sold are also increasing equally. So the more you spend on TV ads, the more sales you can expect. I'll close it. Now let's look at how sales vary based on radio advertising expenditure. I'll copy this. Paste it, and under y-axis I'll change it to radio, and I'll take the color now as, let's say, blue color. I'll run it. Now if I to zoom in, now if you look at the blue dots, it is not that linear compared to our previous graph. You can see there are a few data points like this that show the sales were not good even after spending decent money on radio ads. But still you can expect a decent amount of sales if you are willing to spend on radio advertising. Close it. Let's now look at how sales will vary based on the newspaper advertising expenditure. I'll change the radio to newspaper column, and this time I'll take color as green. I'll run it. Let me zoom in. You can see the plots are very haphazardly present. The data is completely non-linear, and there seems to be a low correlation between the sales and newspaper advertising expenditure. Now if you want to look at these plots at a time, you can use the pairs function. So I'll type pairs and then pass in my variable name, which is ads. I'll run it. Let me zoom in. So this is our plot, and you can see this has all the visualizations. So you can see the TV sales. Now you can see the sales that were made with radio expenditure and with the newspaper expenditure as well. I'll close it. Moving ahead, let's check the correlation between the variables and see what insight we can get. We will use the core function or COR function and build a correlation matrix. First, let me go ahead and install the core plot package. So I'll give a comment, correlation analysis. For this, I will have to install the core plot package. I have already got it installed. Then I'll call this function using library. I'll run it. can see core plot, the version has been uploaded. Now I'll tell you how you can grab only the numeric columns. Now our data only has numeric columns, but still let me tell you how you can do it. Since correlations are based on numeric columns only, this can be done using the sapply function. So for that we have already installed the dplyr library. I'll give a variable name as num.calls, which is numeric columns. Then I'll pass in the sapply function. I'll give the adds variable and I'll check if the variable is numeric or not. So I'll use is.numeric. Let me run it. And now let's display what's there in num.calls. You can see it says TV, it's true, which means TV has numeric values, even radio has numeric values. Similarly for newspaper and sales also. Then I'll use the correlation function, which is COR, to display the correlations between the variables. So I'll give my variable name as cor.data, and then I'll take the core function, pass in the adds variable, and I'll only filter out the numeric columns. So comma numeric columns means we need all the rows and the selected columns. Let me run it. And now to display, let me call cor.data again. So this is our correlation output. As you can see, the correlation values are all above 0, which means there is a positive correlation between the variables, and a change in one of the independent variables will have a positive impact on the sales numbers. TV ads have the maximum correlation with sales and the value is around 0.78. Then there is radio advertising, which has correlation of about 0.57 with sales, and newspaper ads have the lowest correlation compared to the other two, which is at 0.22. Now you can also build a correlation matrix using the correlation plot method. This will give you a visual representation of the correlation between the variables. So let's see how we can do that. I'll type core plot and I'll give core.data and I'll pass a method as color. If I zoom in, you can see this is our correlation matrix. On the right, you can see the scale. So -1 is for negative correlation. Then there's light red, 0, which is almost white color. Then there's light blue, and finally dark blue for the maximum positive correlation. The diagonals are dark blue, which represents the same variables as in rows and in columns. So it's dark blue. TV ads and radio ads have the next highest correlation, while newspaper ads have the lowest correlation with sales. With that, let's jump into the most important part of this analysis, which is building our regression model. First, we will look at a simple linear regression model where we will take one input variable, that is TV ads. I'll be using the lm function or the linear model function to build the model. So I'll give a comment, simple linear regression. I'll take a variable name as model underscore simple, and then using lm function I'll give my target variable, which is sales, and using tilde, I'll give my independent variable which is TV and data as ads. I'll run it. Now that we have built our linear regression model, let's check the summary. Take summary function and I'll pass in model underscore simple. Let me run it. Now if I expand this, you can see our intercept estimate is around 7.03. So when the TV advertising budget is 0, we can expect sales to be around 7030 or 7030. Also remember, we are operating in units of thousand, and for every $1,000 increase in the TV advertising budget, we can expect the average increase in sales to be around 47 units. Now the same summary can be checked using the tidy function present in the broom package. So if I call tidy and I'll give the model name which is model underscore simple, I'll run it. So there you go. This gives us a tidy representation of the summary figures. Now let's build a regression model with more than one input variable. So we'll build a multiple linear regression model. I'll take my variable name as model underscore multiple this time, and I'll use the same lm function. I'll pass in the sales and using tilde I'll take all the column names. Stevie, then I'll use an addition operator, then I'll take in newspaper followed by the radio column, and then I'll take my data as ads. Let's run it. I'll follow the same drill. Let me now call the summary function over this newly created model. So I'll write summary and I'll select my model name as model underscore multiple. Let me run it. So the interpretation of our coefficients is the same as in simple linear regression model. First, we see that our coefficients for TV and radio advertising budget are statistically significant, since our p-value is less than 0.05, while the coefficient of newspaper is not, which is around 0.86. Thus, changes in the newspaper budget does not appear to have any relationship with changes in sales. However, for TV ads, our coefficient suggests that for every $1,000 increase in TV advertising budget, holding any other predictors constant, we can expect an increase in sales of 45 units on average. Similarly, the radio coefficient suggests that for every $1,000 increase in radio advertising, holding all the other predictors constant, we can expect an increase of 188 sales units on an average. Now you can also call the tidy function over this multiple linear regression model. So let me do that. I'll call tidy and I'll pass in model underscore multiple. You can see it has given the output. Now you can also find the coefficients of the model using another method. It's called the coefficient matrix. Here is how you can do that. So take a variable name and I'll use the summary function. I'll pass in model underscore multiple, and using the dollar symbol I'll take the parameter as coefficient. Let me call C coefficient now. So these are the coefficients of different variables. Let me now show you another example of how you can train a linear regression model using the CA tools library. First, I'll take a seed value, a random seed value of say 101. Next, I will split the data into training and testing sets. I'll take 70% for training the data and 30% for testing the data. So I'll use a variable sample, then I'll call sample.split, take adds, and then I'll use another parameter called split ratio, and I'll take the split ratio as 0.7, which is 70%. I'll run it, and then I'll use another variable called train and take the subset of the sample, pass in my adds variable, and I'll select sample is equal to true. Similarly, I'll take another variable called test. I'll use my subset function and given the same parameters, but this time I'll take sample is equal to false, which means the test sample dataset won't have any values that are present in train dataset. I'll run it. Now we will use the same lm function to create our model. So I'll take model as my variable and assign it to lm function. So I'll assign the linear model to the model variable. I'll take sales as my target column, use the tilde followed by a dot, which means I'm taking all the variables in terms of the independent variables, and then I'll select my train dataset. With that, let's check the summary as well. So this is the summary of our newly created model. Now you can also check the residual collected from the trained model using the residuals function. Let me go ahead and assign a variable called res for residual, and I'll use the residuals function. Pass in my model. Then I'll convert the residuals into a data frame. So I'll use the as.dataframe function and pass in res. Now you can check the residuals. So these are the residual values. Now it's time to make our predictions using the test dataset. I'll use the predict function for this. Let me take another variable called sales.predictions, and I'll use the predict function, pass in my model followed by the test dataset. Now I'll run it. Then let me call sales.prediction to display the values. As you can see, these are my predicted sales values. Now let me combine these predicted sales values to our original sales for the test data. For that, I'll use the cbind function and pass the column names. I'll take another variable called results and use the cbind function I'll take sales.predictions and I'll consider the sales column from the test data. Let me check the values now. So you have the predicted sales values and the original values of sales, but you can see the columns don't have any name assigned to them. So let me go ahead and assign the column names using the call names function and convert it into a data frame to make it look better. So I'll use the call names function and pass in my results variable. Then I'll take a vector and give the column names as pred for predicted values and let's say real for the original values. We run it. Now I'll convert this into a data frame. So I'll use as.data.frame and give my results variable. Now if I display results, you can see, go on top, you can see the columns have been assigned successfully. So on the left you have the predicted values and on the right you have the real values. So we have successfully built our linear regression model and predicted the sales values using linear regression in R. You can also go ahead and find the accuracy of this model to know how good your model is. We won't be covering that as part of this tutorial. I'll leave it for you and encourage you to do some research on how you can find the accuracy of a linear regression model. You will come across terms such as mean squared error, root mean squared error, and R squared value. If you are able to find the accuracy, please post the results in the comment section, or if you face any issues with it, please post your queries. We'll be happy to help you.
According to the industry reports, the global data analytics market is expected to hit over $650 billion by 2029. And that's right, we are talking about a field that's booming faster than ever. And in 2025, data analysts are not just in demand, they are in command. Now, if you love playing with numbers, if solving problems excites you, if turning messy data into meaningful insights sounds like magic, then becoming a data analyst might be the perfect career choice for you. In this video, I've got you covered with the exact step-by-step roadmap to become a successful data analyst in 2025. I'll walk you through the key skills you need, tools to master, real-world projects to build, and we will also talk about all the data analyst salaries, how they grow with experience, what companies pay, and tips on negotiating the best offer. And because I keep seeing these questions pop up online and in Google searches, so I'll also answer the most frequently asked questions about data analytics career. Is data analysis a good career or not? And the best part is, you'll get to learn the free learning resources so that you can start right now without spending a single dollar. So grab a notebook, get comfortable, and let's break down how you can start your journey to become a high-paid data analyst in 2025, even if you're starting from scratch. So let's dive right in. Now, before we jump into the roadmap, let's quickly answer some questions I see asked again and again online and so forums. The first question is, data analysis a good career choice or not? The answer is absolutely yes. Every company today runs on technology and technology produces data. Analyzing this data helps companies make smart decisions, innovate, and plan for the future. As more organizations rely on data-driven decision-making, the demand for data analysts keeps growing. It's a career that's challenging, rewarding, and constantly evolving, especially with new AI tools and visualization techniques coming in. The second question is, are data analysts well paid or not? The answer is yes. Salaries vary based on experience, location, industry, but data analysts generally earn competitive pay. I'll cover detailed salary ranges shortly in the video coming. Now, the third question which I have seen is, what qualifications do I actually need? Now the answer is you don't have to get a fancy degree. Many data analysts start with skills in Excel, SQL, and a programming language like Python, plus a portfolio of projects and certifications definitely help too. Fourth question, is data analysis an IT job or not? The answer is yes, it is. It sits at the intersection of IT and business. While it involves technical skills like coding and databases, it's also about understanding business problems and providing insights to help decision makers. Now let's start with step-by-step detailed roadmap. Now let's talk about what is data analytics with a simple detective example. Imagine you are a detective solving a mystery. Your clues are data, sales numbers, customer reviews, website clicks. You collect the clues, clean them up, and analyze them to find the truth. Data analytics is exactly that, solving business mysteries using data. Now here's a 4-step detective approach. First is descriptive analytics, what happened, like checking last month's store sales to see which product sold the best. The second is diagnostic analytics. This means why did it happen? Maybe sales dropped because a competitor had a sale. The third one is predictive analytics. This means what might happen next, predicting which product might be popular next season. The fourth one is prescriptive analytics. What should we do? Deciding to run discounts to boost sales. Now let's take an example. For example, imagine a retail company which is trying to understand why sales dropped last quarter. A data analyst would gather sales data, customer feedback, and market trends. They might discover that a competitor launched a similar product at a lower price, causing customers to switch. With this insight, the company can adjust its pricing strategy or improve its product to regain market share. Let's move on to the first step, which is mastering Excel and basic stats. Now, before fancy tools, Excel is your first best friend. Think of it as a digital notebook for data. You need to learn functions like sum, adds up numbers like total sales. The second is you need to learn about average, find average price or rating. Then the third function is if statements. If sales are over 100, mark as good. Fourth one is VLOOKUP. Imagine a giant phone book that lets you find customer information instantly. Then we have pivot tables where you can just have a quick summary machine that groups data and shows total. Talking about the basic statistics, it's just like learning the language of data, understanding average, how spread out data is, and what's normal or unusual happening. Example, if average sales are 100 units, but some days sell 10 and others 200, then stats help you understand this difference. Now let's move on to our second step, which is learning SQL. Talking to databases like a pro. Now think of databases like huge libraries storing your data books, and SQL is the language you need to use to ask the librarian for exactly the books, that is the data which you want. You need to learn commands like select, which gives me, let's suppose, give me all the sales from January, where only sales from New York. Join will give you the combined. For example, instead of looking through every book manually, SQL helps get your information fast and precise. Now let's move on to our third step, which is picking your programming language, which is Python or R. Now programming languages are like detective gadgets, powerful tools to solve complex problems faster. At first we have Python. This is easy to learn. It's just like a Swiss Army knife. We can use pandas to manage data and matplotlib to make charts. Then we have R, which is focused on stats and beautiful graphs with tools like dplyr and ggplot2. You can start with Python if you're new. It's beginner friendly and it is widely used. Let's move on to our fourth step, which is collecting and cleaning data, getting your clues ready. The raw data is like a puzzle pieces covered in mud. You need to have to clean them before solving the puzzle. You'll have to collect data from websites like web scraping, file, APIs, tools that share data between apps or database. Then you need to clean data by filling missing information, removing duplicates, fixing errors. Then you'll need to transform data to the right format, like converting dates into the same style. For example, if one customer's birth date is 1 to 1990 and another one is 1919 to 1. Cleaning makes them consistent. Now let's look at your fifth step, which is analyzing data and visualizing the story. Now is the time to play detective and find the patterns. You need to use averages, sum, and understand the data. If two things move together, for example, more ice cream sales, then you need to test with hypothesis testing, use regressions to see how advertising affect the sales, and visualization helps turns numbers into pictures. Now tools like Tableau and Power BI make it easy to create charts and dashboard. Python's matplotlib or C help you customize visuals. For example, instead of giving you a boring spreadsheet, you show a colorful chart that everyone can understand instantly. Now let's move on to the sixth step, which is learning machine learning basics. Your detective's crystal machine learning help computers learn patterns from data and make predictions. At first, we've got unsupervised learning. Now the computer finds hidden groups by itself, like grouping customers by shopping habits. Then we've got supervised learning. You need to teach the computer using examples like showing pictures of cats and dogs so it can identify them later. You don't need to be a machine learning expert, but knowing the basics will definitely make you stand out. The seventh step is optional, which is big data and cloud, super tools for huge puzzles. Now, big companies handle mountains of data. Think millions of customers and billions of clicks. They use tools like Hadoop and Spark to break down and process huge data quickly, like having a team of detectives working together. And cloud platforms like AWS and Azure let you store and work with data online. No big servers are needed. Now the eighth step is building real projects and a portfolio. Show what you can do. Now nothing beats practice. Work on projects like grouping customers, buying habits, predicting next month's sales, creating dashboards for easy understanding, joining Kaggle's competition where you solve real. And these projects are your proof to employers that you can do the job. Then you can also apply to Freelancer, Upwork, and you can check in job postings in Indeed and Glassdoor. We also have GitHub where you can find the repositories. Now, the ninth step is keep learning and networking, stay sharp and connected. Now, data is always changing, so keep learning. Read blogs like Towards Data Science, join LinkedIn groups and Reddit communities, attend free webinars and meetups. Now let's talk about some free resources. Now to make it easy, here are some free places to learn all of these skills. You can go to LinkedIn and check some blogs from there. And then we have Simplilearn's Data Analyst course, which I've already discussed right now. You can just enroll in that. And we also have Google Data Analytics Professional Certificate from Google, and it's a free course. We also have full courses from Simplilearn. It's a data analyst full course. You can just find it in the comment section below. Then you can also enroll yourself in Kaggle competitions, network and learn from LinkedIn groups, Reddit data science community, and free webinars. Now let's talk about the data analyst salary and career growth. Now that you know the skills and steps, let's talk about the big question. How much can you actually earn as a data analyst? The truth is, data analysts are in huge demand today, and the salaries reflect that. So now let's talk about the entry-level data analyst position, which is around 0 to 2 years of experience. So if you're just starting, maybe fresh or looking to switch careers, you can expect around $55,000 to $75,000 per year in US, and in India, you can expect around 6 lakh to 8 lakh rupees per month. Talking about which companies, Google, Amazon, Microsoft, financial firms and healthcare organizations need data experts to make smart decisions. For mid-level data analysts in US, you can expect salary around $75,000 to $100,000 with an experience around 3 to 5 years. And in India, you can expect around 12 lakh rupees to 18 lakh rupees over the experience of 3 to 5 years. Talking about the senior analyst position, senior data, over 5+ years of experience in the US, you can expect around $100,000 till $140,000 plus. And in India, you can expect with 5+ years of experience, around 20 lakhs per annum. Obviously more than this. So let's look at the job outlook in future. So obviously big tech cities like San Francisco, New York and Seattle will offer the highest salaries, but cost of living is higher. The remote jobs are leveling up. Finance, healthcare, and AI-focused companies often pay more. Getting certifications from Google, Microsoft, Simplilearn, AWS, or specialized analytics programs can help you boost your pay scale. So that's your full step-by-step roadmap to become a data analyst in 2025. Now follow this path, practice often, and stay curious.
Hello and welcome. Welcome to Data Analytics with R from Simplilearn. So, are you excited to begin with today's session? Yes, you are? Okay, great. I'm excited as well to be a part of this session. What are we going to cover in today's session? We will cover a couple of topics. We will begin with understanding the basics. We will focus on why data analytics and the importance of data analytics. And then, what is data analytics? We will also focus on understanding the life cycle of data analytics. And I'll also try to give you some real-time examples so that we can relate these concepts with the real-time examples or scenarios. And then we will understand the types of analytics and what do they mean. We will also focus on the benefits of using R. For this session, we will be using R Studio tool. Hence, we have to understand why we use R for data analysis. And finally, we will perform some hands-on exercise. In today's session, we will only focus on how to import the data, how to structure the data, and also how to create some beautiful visualizations by using R Studio. All right?
Python and R are top programming languages that are in demand in data science community. Both have their own pros and cons. Therefore, it is vital that you understand the crucial differences between the two programming languages and decide which one is the best fit for you. After watching this video, you will understand which language is better for you in terms of different parameters. Before unwrapping today's topic, I request you to subscribe to our channel and press the bell icon to never miss any updates from Simplilearn. And also get notified every time you get a similar video. Now let us look at what are we covering today. We are covering Introduction to R and Python, parameters in R and Python, best tools and libraries offered by Python and R, and conclusion to the topic. Introduction to R and Python. Let me ask few queries regarding Python and R. R language is superficially related to Python, C, C++, Java. Please leave your answer in the comment section below and stay tuned to get the answer. And another question is, which one of the following is a Python file extension? .p, .python, .py and .pyt. Please leave your answer in the comment section below. Coming to Introduction to Python and R. R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial and Python has some incredible visualization tool. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, Seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. Recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language. Next question was, which one of the following is a Python file extension? It was an easy question. Answer for that question is .py.
So, firstly, let us understand why data analytics. Can somebody here tell me why data analytics and why is it used in organizations? So, let us understand why data analytics and what is the use of data analytics. As we all know that data is growing exponentially year over year. It is collected and it is also available everywhere. Data is no more just available in structured format, but it is also available in semi-structured and unstructured format. I'm sure you would have come across this term called as sentiment analysis pretty often, right? What does that mean? Can we perform that in data analytics? Yes, right? We use some natural language processing models, try to identify what are the good reviews, what are the bad reviews spoken by the customer, correct? So we try to classify the text based on the good, bad, and the neutral. So that is what sentiment analysis is about. So for that, to perform that activity, we have to also do some data analytics. Now that companies have realized the importance of these informations, not just structured but also unstructured data format, the companies have started utilizing these data to take some crucial business decisions, which can boost their business and also which can increase the efficiency of the business. So now that the raw data is accessible to the organizations, it becomes very important that the data is also stored well. I'm sure you all have pretty much heard about data warehouse. In the last few decades, the trend was mostly on the data warehouses, the business intelligence tools. So the data warehouse used to collect this data, pre-process the data, and also filter the data and make it available in a structured format for further analysis. However, now that is not the scenario. A term coined as data lake is available, and many firms are utilizing data lake because it is a central repository which stores the raw data in form of structured and unstructured data. And now let us take a scenario. Let us choose one of the participants here, Mark. So Mark has recently joined an organization as a data analyst, or in essence a data scientist. The business connects with him and says that, Mark, we have a business problem for you and we expect you to provide us a data analytics solution. So Mark sits with the stakeholders and he listens very carefully to the business question. So the business question says that we have a couple of products which are performing really well in the market and we see higher sales. And some of the products are just not catching up in the market and we experience lower sales. Can you help us identify what are the factors driving these higher sales and the lower sales? Now, Mark has to think with the data scientist mindset and be prepared to ask them right questions. Some questions such as, do you have the price of all these products available in the database? And can I also know what is the duration of data availability? And also, Mark can ask some questions such as, do you also have some features of these individual products already captured in your database? So these are some of the interesting questions that makes sense to the business, and the conversation continues, which also means that data is not only information. Data analysis is about unlocking insightful information from this raw data. And hence, data analysis plays an important role in discovering insightful information, asking questions or answering the right questions, and also predicting the future or the unknowns. And to perform all these activities, we use data analytics. So are you all with me so far? Are we on the same page? Yes? Great. Now the question is, what is data analytics? So can somebody tell me what is data analytics? So let us see what is data analytics. We understood why data analytics and the importance of it. But to perform any activities, there has to be a process, right? So data analytics is a process to extract meaningful insights from data. Now let us continue with the scenario of Mark. So Mark now understands the business problem, and he has also started asking some relevant questions to the stakeholders, and he has also got the answers in return. He may start thinking about what could be the suitable solution for this. He may have to perform some exploratory data analysis to unlock some hidden patterns, to identify some correlation between the variables, and to also know which are the key variables in the data set. And he may also have to view the market trend, which means he may have to see that how the sales has been performing across the years or across the months. There might be some insightful information there. He may see that the sales has been growing exponentially for some of the products, and some may be volatile, some may have some seasonality pattern or a cyclical pattern, etc. And also he may have to focus on the customer preferences via the customer reviews and do some sentiment analysis. So now let us understand what are those life cycles of data analytics. We will begin with the discovery phase. This is the first phase. Now that Mark has understood the business problem, he will also start focusing on identifying the resources, that is the data resources. Some may be internal data resources that is available within the firm, could be some transactional data, and some external data sources may be via web scraping, identifying and capturing some competitor price on the products. After gathering all of these right data, Mark will focus on data preparation, which is the next phase. Now Mark, either individually or along with the team, will start focusing on the data preparation, which includes data wrangling, which means cleansing the data, imputing the records if there are any missing values, or he may also go ahead by removing those records if they are not required, and also doing some exploratory data analysis, which can include some statistical analysis like looking at the data distributions, understanding the summary of this data distribution at individual variable level, doing some bivariate analysis, and also trying to figure out which are the important variables that might be required for the model building phase. After performing all of these EDA activities, which also include some visualization, Mark will now sit with his team and try to identify the suitable models. The suitable models could be simple statistical techniques, or it can also be some machine learning models. So let's say that Mark and his team has identified some 5 models that can provide the required result. And out of these 5 models, they will filter down and they will prioritize only 3 models. Now there are only 3 models that Mark and his team have finalized. After this, they start focusing on model building activity. Now for model building activity, they have a data set already in place. So this data set will be split into training data set and test data set. It's not only training and test, we can also do some validation in between training and test. But here let's focus on training and test data set. He will separate 75% of the data as training and 25% of the data as test. Now if your question is that why perform this activity of splitting the training data set and test, can't we just go with the one single data set? What happens if you just utilize one single data set? Let us say that you have used the original data set and also executed this data in one of the selected model, and you will also observe the accuracy. Let's say the accuracy returned is about 98%. 98% is a very good accuracy percentage. And you may also be overconfident because of this. That may be a case due to overfitting. Now what will happen when you add some new records into this data set and you rerun it? The executed model may not return you the same accuracy what you had seen. The accuracy might be 72%. Now that's not fair, right? To avoid these overfitting issues, we ensure that some new records are tested separately. So hence we locate 25% of the data to the test data set, and then we predict those records, the unknown records which is located in the test data set. We predict them and then we test the accuracy of training data set and the test data set, and we make a comparison. Now let us say the accuracy result of training is 98% and the test is 97%. In this case, we can say that the model is performing really well. However, while executing the model, there are certain things that has to be considered. For example, inclusion of the parameters, tuning the parameter, which also will execute the optimal results. So this is very important. Now let's say after performing this model building, the time comes to analyze the results. That is the next phase. Now the team will sit and analyze the result, and they will notice that out of the 3 filtered models, only 2 models are returning excellent accuracies. They will sit with the business team and they will also explain them the result and what are the activities that they have performed to obtain this result. Some of the stakeholders may be technically savvy, some of them may be non-technical people. So it has to be very important that you also communicate these results accordingly. Alright, now that you have the results, you will also gauge them based on the business objective, which was developed in phase 1. Looking at the results of the 2 models, now the business might select one of the model and say that, okay, this particular model seems to be returning some right information and it also appears valid to us. Let's go ahead with this one model. So finally, the result and the model needs to be operationalized. And that is where the team will start documenting the business problems, the steps that were taken for executing the models, and they will include all the codes and the findings. And finally, they will implement this model so that the business can view the results and also utilize them for strategic decision making at your firm. So are we good so far with the understanding of the life cycle? Alright, great. Now let us focus on the types of analytics. What are the types of analytics? Can somebody tell me which are the types of analytics you are aware of? Okay, predictive analytics, great. Descriptive analytics, good. Alright, good enough. Now let us focus on this example of Google Maps. So as we look at this particular Google map, we understand that the blue color route is nothing but the route direction from Sacramento to Florin. And also we see a display of the duration estimated as well the distance to travel from Sacramento to Florin. As well we see another route here that is gray colored. This is a substitute route or the connecting route just to avoid the traffic, which is in orange within the blue color route. So the gray colored route as well shows us the estimated duration to travel as well the distance. Now let us understand what is descriptive analytics and why do we focus on this particular map example. As we understand the route map, the estimated duration as well the distance to travel via the blue color route as well the gray color route. This is one way of understanding descriptive analytics, as in what is happening. But there is another way of understanding descriptive analytics, that is by focusing on summarized past data. And this is a descriptive analytics. We see that what had happened in the previous year. Now let us focus on predictive analytics. What is predictive analytics? This type of analytics looks into the historical and present data to make predictions of the future. What does this mean? So Google has already suggested the best route, which is the blue color route, to travel from Sacramento to Florin, and the duration is 18 minutes and distance is 9.7 miles. Let's assume that Google Map has already collected historical data of this particular route, and based on the available data, their model has predicted the best route and also the duration that will be taken to travel from Sacramento to Florin. Now let us focus on prescriptive analytics. Prescriptive analytics describes the solution to a particular problem. What was the problem in this case on the predicted best route? Some predictions on the traffic congestions. And that's when Google Map recommends the substitute routes, correct? Now these substitute routes are also prescribed by Google Map as a recommendation. So prescriptive analytics is nothing but a solution and a recommendation provided for a problem. So in this case, we have the best route and we also have other substitute routes. So let's quickly summarize. Descriptive analytics is about summarizing the past data or to see what is happening, for example, in the Google Maps scenario. Predictive analytics is about what would happen. And prescriptive analytics is about prescribing the solution, the best solution and the recommended solutions. Now let us refer back to Mark's earlier scenario. Mark along with his team identified the best model. They also did some testing and they identified the best results, and they also finalized on one particular model. Based on that particular model, now the results have to be provided in such a way that they are the best results and also the recommendations. Correct? So it may not be just one single solution. It may be a solution with couple of other recommendations as well. So that is exactly what happens in the entire process of data analytics. I hope this has been clear so far. Yes? Okay. And now let us focus on benefits of using R. Why do companies extensively use R for data analysis, and why is it chosen? Firstly, R is an open source programming language, which means that there is no license required to work with R. And R does not require you to have a coding experience, which means that a non-technical person in your team can also learn R very easily and start coding or building models in few lines of codes. R can also be used with other programming languages such as Java, C++, and Python. And the integration of R with other programming tools or BI tools is very simple and easy. And various statistical models are readily available in R, which also means that there are plenty of inbuilt libraries and packages already available. And reporting the results of an analysis becomes easier by using these inbuilt packages and for creation of these models in just simple few lines code. With this understanding of the benefits of using R, let us quickly hop on to RStudio and start performing the hands-on exercise for data analysis. For this exercise, we will use a dataset named as demographics, which is in a .csv file type. Firstly, let us load the dataset to RStudio, and we will locate this in a variable named as demo. We also refer to this as a data frame. And now you will notice that a variable is created in an environment section, which is in the bottom right hand side of the RStudio window. And this particular variable comprises of 510 observations or records with 8 variables. Let us simply expand this particular data frame and have a quick check on the data structure and understand the data types. This particular data frame includes variables such as age, marital, income, the unit of income is dollar per day, education levels, the car price, car category with several levels, gender, and retired status. Now let us view the top 6 records of this particular data set. For this, let's simply type head of demo. And the result is now visible in the console section. If you're interested to view all the records, then simply type view of demo. And this new window will show you every single record that is being loaded to RStudio. You may also simply apply the filters and the filter section here on individual categorical variables. Now that we have loaded the dataset and also viewed individual records, let us focus on creating subsets of records by applying filters on individual variables or multiple variables. So firstly, let us apply filter on gender. we will only retrieve the records where gender is equal to female, and we will locate these records in a variable named as demo2. As you notice now in the environment section, the second variable is also created, that is demo. And this now is comprising of 250 observations, which means the records are filtered down to only gender female. Next, let us see how to apply a filter on income variable. Let us only retrieve the records where income is greater than 100. Let's view the result. As we see here, all the records include income greater than 100. Now let us modify this query, and we will ensure that the retrieved records includes income greater than 100, and also specific variables are returned. Let's say we only want to have the first variable, third variable, and the seventh variable returned as the result. Let's have a quick check. So we only have the first, third, and the seventh variable returned. How about we only exclude the variable 6 to 8? For this, we include a prefix of minus sign. And now let us see what is the result. We have the variables from first to the fifth variable. However, we don't have 6, 7, and 8th variable. I hope it's clear so far. Yes? Alright. Now let us see how can we apply condition by including both the variables, that is gender and income, and then we will filter the record and create a subset of data. Now let's view the result. Income is greater than 100 and the gender is only female. This is one way of creating subsets. However, now let us see how to use the subset command and create the subset. Let's create a subset of records by applying filter on marital status and age. We'll only retrieve records where marital status is equal to married and age is greater than 35. Let's now view the result. So here we have the age greater than 35 and marital status is married. Let's use the same code, and this time we will retrieve selected variables. Let's say variables ranging from 1 to 3. Let's have a quick check. So there are 3 variables. Age is greater than 35 and marital status is married. Now let us see how to structure the data by sorting the data frame in ascending and in descending order. We will apply this order function on the variable income. Firstly, let us see how to order income variable in ascending order. Let's do a quick check. And here we have income in ascending order. Now let's see how to modify the same code and view the records with income in descending order. So we have now the income in descending order. How about include two variables and sort the variables accordingly? Firstly, we will sort the records by ordering income and age in ascending order. Let's quickly view the result. We have income in ascending and age as well in ascending. Let's now modify this code. This time we will order income in descending and age in ascending. Let us view the result. So the income is in descending and age is in ascending order. So hope this is clear on how to sort the data frame by ascending and descending order per variable or by using multiple variables. With this, we will focus on learning statistical analysis. How to perform statistical analysis on individual variable or multiple variable. Let's start by understanding the data distribution of variable income so that we identify what is the minimum value of income, what is the maximum, what is the range, what is median, what is the mean, and we will also focus on the quantile distribution, which is also analyzed in a box plot. What is the minimum value in the variable income? It's 9. And what is the maximum? So we have the maximum value. Now let us see what's the range. So the range shows you the result with minimum and the maximum value. How about the difference of maximum and the minimum? Now let us focus on other summaries of data distribution for this variable income. Let's identify what is the mean value of income. The mean is 78. Let's also understand what is the standard deviation. Alright, so the standard deviation is $112. Let us see what is the variance. The variance should be larger than the standard deviation. Now let's say what is the median absolute deviation. As you notice here, the median absolute deviation value is lower than standard deviation. Why do we make this comparison? From this, it is evident that median absolute deviation is robust to outliers and standard deviation is sensitive to outliers and also to the change in the mean value. Now let us understand the quantile distribution. This is the same analysis that is visualized in a box plot, ranging from 0% to 100%, identifying the individual data points. And we can also refer and compare this to the min, the max, and the median values. Let us quickly see what is the median value of income. As you notice here, the median is 45. As well, the 50th percent of quantile is 45, which means 0% is minimum and 100% is the maximum value. Now, if your question is what is 25% and 75%, this is again used for identifying the range of interquartile. The interquartile range is nothing but the difference of 75% minus the 25%. Let's quickly see what is the IQR of income. The IQR of income is 58. Let us do a quick check. 75% of quantile is 86 and 25% of quantile is 28. And the value is 58, which is equal to the IQR result. Now that we have focused on the statistical analysis of the individual variables data distribution, let us focus on the data visualization. In this, we will have a pictorial representation of analysis to identify the outliers, to see what is the minimum and where do we see the data densely populated and how is it scattered, etc. We will begin with creating a histogram. Now, histogram can be used for univariate analysis, which means in this scenario we will consider income variable and we will see how the count of income ranges gets distributed in a histogram. For this, we will have to install a package called as ggplot2 and also call this library ggplot. Let us install the package. Now let us call the library. Alright, and we are ready now to begin with visualization. For this, we will use the geometric object histogram on the data demo data frame. Let me expand this window so that the code is visible, and also use an aesthetic mapping for variable income. This will be helpful for filling colors or filtrations, etc. And only include 30 bins with individual bin size width of 100, which means there will be 100 incomes in individual bins. Let's quickly look at the distribution of this histogram. As you notice, there are a couple of outliers. The counts of these income range are very limited. However, we see the densely populated income ranges with higher counts between 0 to $200 per day. This is also a way to identify and segment the customers based on their income ranges. Now let us see how to change the color of this histogram and also the border of the histogram. For this, we will include some additional options such as fill with blue color, and the border color is black. Now, as you notice here, the executed code provides us the histogram with blue color bars and black color border lines. Now we will focus on creating a facet grid. Facet grid is also an aesthetic mapping object. We will see how to enable the multiple histograms across the marital status and the genders, so that we identify how the income is distributed for individual marital status as well the genders. Let's zoom this view and have a look at it. As you notice here, There are some interesting outliers here in the data distribution. Female unmarried drawing higher income, and male unmarried and married also drawing higher income as compared to the females. Whereas if you notice that the female unmarried is drawing much higher income than the male. This may also be very much related to the age. Now let us see how to create a stacked histogram. When I say a stacked histogram, I mean instead of filling the color, we will fill the gender, so that there is a stack within the histogram. So as you notice here, I have made couple of changes. I have included fill equal to gender within the aesthetic mapping. Now let us look at this histogram. As you see here, the gender is filled in the histogram, hence we have stacked distribution of female and the male. Now let us focus on creating a bar chart with education versus income, where we can identify the education levels and the income ranges for these education levels. As you notice here, we are going to create a visualization where we have the aggregation in form of mean, and the geometric object used here is bar plot. Now let's zoom this view and understand which education level have higher average income. So as we see here, the blue color bar is the post undergraduate degree, which means this education level draws higher average income as compared to other education levels. Now let's create a histogram where we will see car price and the number of cars for individual category. Let's look at this visualization. This visualization provides us some interesting insight. Just by looking at the distribution of the car prices and the counts of the cars at the car category, economy, and even the luxury. Luxury car category or car price is pretty much distributed, whereas economy car category is dense, which means that we could also look back into the income and age variables and try to figure out further more insights, and then segment the customers for further targeting of these customers. Now what happens if we simply change this bin width to 30? As you observe here, changing the bin width or increasing the bin width will also reduce the number of bins. Now we only have 4 bins here, and the car category is filled. That is what we have enabled within the aesthetic mapping. And we see some more interesting insight. As you look at the standard and the luxury car category, the car prices are pretty much overlapping for the car category luxury and standard. This could be the starting car price of the luxury brands. Now let us create a clustered bar chart. Let's look at this visualization. In this visualization, as you observe, though we have enabled fill equal to gender in the aesthetic mapping, we do not have the view in stacked form, but we have the bars one besides the other. It is also because we have enabled a position called as position equal to dodge in the code. Now, what is the insight that we can draw from this visualization? As you see, postgraduate degree with female gender is drawing higher average income as compared to any other education level. Now let us see how to create a box plot for variable income across the genders. So the box plot can be enabled if there is a bivariate analysis to be performed on a continuous variable and a categorical variable, or multiple categorical variables with a continuous variable. Now let's look at this visualization. What does this say? We have data distribution of income for individual genders, that is for female and the male, and we also notice outliers here. Anything above this whisker is considered to be outliers. It might make more sense if we also include some coloring for these outliers, maybe also enable shape. So now we have colored the outliers and it's colored orange. Let's see if we can also enable the shapes. And now we have here the outlier color as well the shape enabled. Now let us see how to enable a violin plot. What is the utility of violin plot? With a box plot, we understand the analysis and the distribution of the data points is to identify the outliers, to know what is the minimum value, what is the max, what is the median, and what are the outliers. But what is the purpose of a violin plot? Let us have a quick check. As you observe, there is some concentration of data points in the bottom of every car category. However, the concentration is higher for standard car category as compared to economy and the luxury. Now this is an interesting insight that you wouldn't have come across in box plot. The box plot is a very good representation for identifying outliers. However, violin plot will help you focus on the nuances which is not captured by the box plot. We can also simply combine the box plot and the violin plot together. Simply include this geo object. Let's zoom this. Now you have a representation of box plot and the violin plot, both combined in a single visualization. Interestingly, you notice the outliers as well the concentration in the bottom of this violin plot. So this could be some interesting insights that you draw and focus on these data points and understand what exactly is happening there. Now let's focus on the density plot, that is density estimate of the histograms rather than just viewing the frequencies. Now we see the frequency in the y-axis across the income distributions. How about enabling the probability as true, so that we enable the density instead of the frequency? So now we have the density in the y-axis, and in the x-axis we still have the income distribution. This is the way of also adding a line plot, which is a density plot on the histogram. Now as you observe here, the density plot is not in the same level as the bar. So let us adjust this line. For this we will include adjust, let's say equal to 3, and now let us see how the visualization appears. Now the density plot is on the same level as the bar. Now let us see how to create a cross table for car category and gender. For this, let us call the library DESCR. Now let us create the visualization, enabling cross table for car category and gender. Let's look at the result in console. As you see here, now we see the counts of the gender for individual car category. The values over here represents that there are 67 females falling within the car category economy and 80 males within the car category economy. And for luxury, we see that the count of female is higher than the male. As well, the proportions. Now, how do you understand what proportions are presented here? We may simply turn off some of the proportions like the t-test, the chi-square, etc. Let us see how to enable that. Now let's look at the result. This looks better. Now that we have the counts, the female counts and the male counts across individual car category, we also see the percentages rather than just looking at the absolute value. So there are 45.6% of female within the car category economy and 54.4% of male within the car category economy. Similarly across rest of the car categories. This kind of cross table or a contingency table is also helpful when you want to analyze the different categorical variables and identify the counts or the proportions. Now let us see how to use a scatter plot of age versus income. Scatter plot is a visualization used for bivariate analysis. When you want to perform some analysis between two continuous variables at a data point level, rather than performing the analysis at an aggregated level, such as sum or mean. And now we have a scatter plot of age versus the income, age in the x-axis and income in the y-axis. Though we do not see any kind of a positive correlation or a negative correlation, but we still see some interesting insights over here. Some of the data points are pretty much scattered and much away from densely populated data points. I hope the learning has been informative and interesting so far. We have covered the concepts of data analytics. As well, we have performed some hands-on, doing some statistical analysis and also creating interesting visualization.
After completing this lesson, you'll be able to explain the various types of graphics available in R, list the possible file formats of graphic outputs, describe the methods to save graphics as files, and describe the procedure to export graphs in RStudio. With its large set of powerful functions, R defines a flexible graphical environment for the visual representation of data. These graphics that help in meaningful data visualization can be viewed on screen, and users can create precisely customized graphical output. The graphics can be saved in various good quality formats, including PDF, PNG, JPEG, WMF, and PS. Typically, graphs are designed on screen, which can then be replotted on, for example, a PDF file. You can also copy and paste in case of a Word or PowerPoint file. Using R, you can produce a variety of graphical images. Basic 3D plots, scatter plots, bar plots, histograms, box plots, and pie charts are 8 standard statistical plots that R can provide. R can also support heat maps, word cloud, kernel density plots, and line charts. Let us look into details of each of these graphics in the subsequent screens. Plotted on vertical or horizontal bars, bar graphs show discrete comparisons among categorical data. The lengths of the bars, each of which represents a category, indicates the frequency, percentage, or proportion of values that fall into the categories. The syntax to create a simple bar chart is barplot x. In the function, x stands for height, which is a matrix or vector. If the height parameter is a vector, the values of the vector give the heights of the sequence of rectangular bars that make up the plot. Let's look at a few examples of how to create vertical and horizontal bar charts. Here, by using an embedded dataset of MT-cars, you can plot bar graphs. To create the first bar graph, you pass gear data to the bar plot function. The default setting for bar orientation is vertical. To plot a horizontal graph, you can pass horizontal equals true as the second parameter to the bar plot function. In the next screen, we'll take a quick look at a few arguments to edit simple bar plots. You can add labels, colors, and titles to the bar plot by using specific arguments. For example, legend.text is useful when the height is a matrix. The arguments xlab and ylab provide the labels for the x-axis and y-axis respectively. Call will define the color of each bar. By default, if height is a vector, then gray is used, whereas if height is a matrix, a gamma-corrected gray palette is used. Main sub gives the overall and subtitles for the bar plot. This demo will show the steps to create a bar chart in R. In this demo, you'll learn how to create bar charts. For this data, we will use the MT-cars dataset available in R. Simple bar charts can be created using the bar plot function. You can create horizontal bars by specifying horizontal equals true as an argument to the bar plot function. You can also add title, colors, and legends to bar plot by specifying details in an argument. For more options or help document, type the given command in the console. You can create a stacked bar plot if the input is a matrix. The stacked bar will indicate each column on the matrix. The argument beside specifies if you want the bars to be stacked or adjacent to each other. By default, beside is set to false, and if height is a matrix, a stacked bar graph results. If you set beside to true, then you get the columns of height as adjacent bars. You can create a stacked bar plot with colors and legends as shown in the screen. Here in this example on the screen, it's a matrix of VS and gear data from MT-CARS datasets. Using the same example as in the previous screen, you can create a grouped bar plot. Reiterating, if the height parameter of bar plot function is a matrix and beside is set to true, then the values in each column are juxtaposed rather than stacked. Here, you use the row names function to set the legend, which will set or retrieve the names of rows or columns of a matrix-like object. In this demo, we'll show the steps to create a stacked bar plot and a grouped bar plot in R. In this demo, you'll learn how to create a stacked bar plot and a grouped bar plot. For this data, we'll use the MT-CARS dataset available in R. For a stacked bar plot and a grouped bar plot, we'll have to create a table-like data from the MT-CARS dataset using the table function. You can create a stacked bar plot using the bar plot function. You can also add title, colors, and legends to bar plot by specifying details in an argument. You can create a grouped bar plot by specifying beside equals true as an argument to the bar plot function. For more options or help document, type the given command in the console. Pie chart is a type of graph in which a circle is divided into sectors, each representing a proportion of the whole. Pie charts are not as popular as dot plots or bar charts in R. You can create pie charts using the function pie x, labels equals. Here, x is a vector of non-negative numerical quantities. The value of x indicates the area of a pie slice. Labels are character strings or expressions that give names to vectors. In the example shown here, you first create the slices vector, which contains numbers 10, 12, 4, 16, and 8. LBLS is the labels vector. Then you pass both these vectors to the pie function as parameters. To set the overall title for the plot, you pass main as a parameter. In this screen, you can see how percentages can be added to the pie chart. In the given example, out of the data vector, you can create the PCT vector and a character vector, LBLS, to add actual labels to the slices. To paste data to the labels vector and add the percentage sign, you use the paste function. Another character vector, call, helps fill in or shade the pie slices. Let's now see how you can create a three-dimensional pie chart. Using the Plottrix package, which has the Pie3D function, you can produce 3D representations of pie charts. There is an explode parameter that enables the pieces to be separated on the chart. However, you first have to install the Plottrix package and reference it using the library function install.packages Plottrix library Plottrix. This demo will show the steps to create a pie chart in R. In this demo, you'll learn how to create pie charts. Pie chart graphics are not available by default. You'll have to install the Plottrix package by using the given command. After installing, you'll have to load the package into R using the given command. For this demo, we'll create a custom dataset using vectors. We can create pie charts using the pie function in the Plottrix package. We can also add a title and labels by specifying the details in an argument. You can create 3D pie charts using the pie 3D function in the Plottrix package. For more options or help document, type the given command in the console. Let's look at another visual representation of data distribution, the histogram. Histograms are a great way to get to know your data. A histogram has an x-axis, a y-axis, and bars of different heights. The bars group ranges of values or continuous categories on the x-axis, and the y-axis shows how frequently the values on the x-axis occur in the data. They display the distribution of a continuous variable and the frequency of scores in each bin on the y-axis by dividing the range of scores into bins on the x-axis. As shown on the screen, the syntax for a histogram is hist in R. For a given set of data values, the generic function hist works out a histogram. If plot equals true, plot.histogram plots the resulting object of class histogram before it's returned. You can create a histogram using the histx function, where x is a vector of values for which you want to plot the histogram. Instead of frequencies, the option frequency equals false plots probability density when you want a histogram of proportion. To control the number of bins, that is bars, use the breaks equals controls option. The break argument helps you control the bin width along with the number of breakpoints you desire. In the example shown on the screen, you can see histograms for dark green colored bins that indicate the miles per gallon or MPG value of the MT cars dataset. A more effective way of visualizing numeric variable distribution, kernel density plots are created using the plot density x function as shown on the screen. Here, x is a density object. You can use the density function to compute the density parameter in plot. In the example shown in this slide, you can create a kernel density graph for the mileage per gallon, or MPG, of MT cars dataset by first calculating its density and then creating the graph. In the second figure, use the polygon function for kernel density of the data for MPG. Vertices are given in X, and colors of the area and the border are given by color equals sky blue and border equals black, respectively. This demo will show the steps to create a histogram and density plot in R. In this demo, you'll learn how to create histograms and a density plot. For this demo, we'll use the mtcars dataset available in R. Histograms can be created using the hist function. You can also specify the number of bins and the color of bin as arguments to the hist function. For the density graph, we'll have to calculate the density of data using the density function and then use the density data to plot the density graph using the plot function. You can color the curve representing density using the polygon function. For more options or help document, type the given commands in the console. Line charts represent a series of data points, called markers, connected by a straight line. This type of graphical visualization is typically used to display data that changes over time. As shown on the screen, the syntax for a line chart is lines, x, y, type equals, where x and y are coordinates of the points. Type indicates the type of plot to be drawn, say L for line and P for points, or B for both. Let's now look at an example of a line chart. In the code shown in this slide, you can create weight and months vectors, and then plot a line and points graph together by calling the plot function. These two vectors are passed as parameters along with main to set the title of the graph as baby weight chart. Also known as whisker diagrams, box plots display the distribution of data that is based on the 5-number summary. Minimum, smallest value in the data set. First quartile, 25th percentile. Median, 50th percentile. Third quartile, 75th percentile. Maximum, largest value in the data set. And data is broken into 4 quartiles in box and whisker plots, and each quartile has the same number of data values. Although these plots do not display the frequency, they show where the middle of the data is, a feature that is really useful if you want to analyze the skewness of your data. The syntax to create a box plot is shown on the screen. Box plot data. A box can be created either for individual variables or for variables by group. As shown on the screen, the syntax is boxplot x data equals, where x is a formula and data equals denotes the data frame providing the data. To make the widths of the box plot proportional to the square roots of the number of observations in the sample, use varWidth equals true. With horizontal equals true, you can reverse the orientation of the axis. Default false means the box plots are vertical, In the code shown here, a vector of numbers was created and the summary function called to print the values of the following variables: minimum, first quartile, median, mean third quartile, maximum. Then the boxplot function was used to display the box plot for the vector of numbers. This demo will show the steps to create line graphs and a box plot in R. In this demo, you'll learn how to create line graphs and a box plot. For this demo, we'll create custom dataset using vectors. We'll use the plot function to create line graphs. Points in a line graph can be connected by specifying type equals b as an argument in the plot function. We can create boxplot using the boxplot function. For more options or help document, type the given commands in the console. Heat maps are two-dimensional representations of data in which the values are represented by colors. The two types of heat maps are simple and elaborate heat maps. A simple heat map provides an immediate visual summary of information. An elaborate heat map allows you to understand complex data sets. Rows and columns can be clustered in a heat map, and the result of the hierarchical clustering computation is shown as a dendrogram in the heat map. As shown on the screen, the syntax to create a heat map is heat map data row v equals NA, column v equals NA. Here, row v and column v decide if and how row and column dendrograms should be calculated or reordered. Data refers to the matrix of values that has to be plotted. Let's look at an example that shows you how to create a heat map. In the code shown here, you can create a data frame by reading data from a CSV file and converting it to a data frame before passing it to the heat map function. Besides data, row v and column v as not applicable, color as 256, and scale as columns to plot a heat map graph are passed to the heat map function. This demo will show the steps to create a heat map in R. In this demo, you'll learn how to create a heat map. For this demo, you'll use the custom dataset imported from a CSV file. A heat map can be constructed using the heat map function. You can also specify the color and scale details as arguments to the heat map function. For more options or help document, type the given command in the console. Also known as tag clouds or text clouds, word clouds highlight the most commonly cited words in a text using a quick visualization. Creating a word cloud in R is relatively simple using a text mining package, TM, and word cloud generator package, word cloud. As shown on the screen, to create a word cloud, use the syntax word cloud, words equal data, frequency equals frequency, min.frequency equals 2, etc. You need to install the word cloud package into the R environment using the install.packages, word count, and library word count commands. In the example on this screen, text data is read from a CSV file, and a word count graph is plotted using the word count function. Passwords, frequency, min.frequency as 2, max.words as 100, and random.order as false. The minimum.frequency argument specifies the minimum frequency below which words that have a frequency lower than that value will not be plotted. The maximum number of words to be plotted are determined by the max.words argument. Random.order means that the words will be plotted in a random order. If false, the words are plotted in decreasing frequency. This demo will show the steps to create a word cloud in R. In this demo, you'll learn how to create a word cloud. Word cloud graphics are not available by default. You'll have to install the word cloud package using the given command, and then load the package using the other command. For this demo, we'll use the custom data imported from the CSV file. We can use the word cloud function to create a word cloud. We can also specify the minimum frequency and maximum word as arguments to the word cloud function. For more options and help document, type the given command in the console. Let's now take a look at the various file formats for saving your plots. R supports several graphic formats and runs on different operating systems. Consequently, there are many formats to choose from depending on what you want to do with the graph, how you connect remotely or locally, and what operating system you use. A few of the available formats are as follows. JPEG doesn't resize and can be used anywhere. PDF, easily resizable and is the best choice with PDF latex. PNG, doesn't resize and can be used anywhere. WMF, easily resizable and works on Windows only, best choice with Word. PostScript, easily resizable and is the best choice with OpenOffice and latex. On the slide, you can see an example to save a graphic output as a file. Regardless of the way you connect or the type of operating system you use, the general method that will work on any computer that has R involves the following steps. Select the file format you want. For example, if you want to save your plot as a JPEG file, use the JPEG driver, which only requires the name of the file that you will use to save the graph. Note that your plot will be stored relative to the current directory, which can be found by typing getwd at the R prompt. Entering your plotting commands next will save those to a file. Then use the dev.off command to close the file. Either you will get a partial plot or nothing in case you fail to enter the dev.off command after you are done with the plotting commands. So if you want to save a JPEG file called myplot.jpg containing a bar graph, you will type the commands as shown on the screen. Recalling the example from the previous screen, you will see that you need to re-enter the commands to save your plot to a file after making a plot to the screen. However, in R, there is another command, dev.copy, which will copy the contents of the graph window to a file without the hassle of re-entering the commands. In this approach, produce the graph as you usually do, and then call dev.copy along with the arguments that are appropriate to the driver. For example, to create a myplot.jpg file from a graph shown by R, type the commands shown on the screen. Until you call dev.auth, the plot isn't actually written to the file. This demo will show the steps to save graphics to a file in R. In this demo, you'll learn how to save graphics to a file. You can save a graphic as a JPEG file using the JPEG function. You'll also have to use the dev.auth function to return the control to the console back again. For more options and help document, type the given command in the console. In this screen, let's see how you can export graphs in RStudio. Follow these steps to export graphs in RStudio, a powerful interface for R. In the Graphics panel of RStudio, click the Plots tab. Click the Explore menu and select the Save as Image menu item. The Save Image window is displayed. Select the image format and directory to save the file. Click the Save button. Follow these steps to export graphs as PDFs in RStudio. In the Graphics panel of RStudio, click the Export menu and select the Save as PDF menu item. Select the directory to save the file. Click the Save button. This demo will show the steps to save graphics using RStudio. In this demo, you'll learn how to save graphics using RStudio. You can save a graphic from RStudio by clicking the Export menu and selecting Save as Image. Select the directory to save the file, and then click Save. Let's summarize the topics covered in this lesson. R includes powerful packages of graphics that help in data visualization: bar chart, pie chart, histogram, kernel density plot, line chart, box plot, heat map, word cloud. You can save the outputs of graphics in various file formats, such as PDF, PNG, and JPEG. You can export graphs in RStudio by using the Graphics panel.
That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for your quick info, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and analytics programs. Simplilearn offers various certifications and postgraduate programs in collaboration with some of the world's leading universities like Caltech, Purdue, IIT Kanpur, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, advanced Excel, machine learning, data visualization, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts working on top-tier data and product companies and academicians from top universities. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your experience and areas of interest.
So what is data analytics? Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large datasets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the metrics to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open-source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open-source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has graphics for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning. Moving on to the applications of data analytics. Data analytics is being used in almost every sector of business these days. Let's discuss a few of them. First, we have retail. Customers expect retailers to understand exactly what they need and when they need it. Data analytics helps retailers meet those demands. Retailers not only have an in-depth understanding of their customers, but they can also predict trends, recommend new products, and boost profitability. Retailers create assortments based on customer preferences, invoke the most relevant engagement strategy for each customer, optimize supply chain and retail operations at every step of the customer journey. The second application is on healthcare. Healthcare industries analyze patient data to provide life-saving diagnosis and treatment options. They also deal with healthcare plans and insurance information to drive key insights. Using analytics, they can discover new drugs and come up with new drug development methods. Advanced analytics allows healthcare companies to improve patient outcomes and experience. Cancer cells and diabetic retinopathy can be discovered using medical imaging. At number 3, we have manufacturing. For manufacturers, solving problem is nothing new. They fight with difficult problems and situations on a daily basis. From complex supply chains to motion applications to labor constraints and equipment breakdowns, they deal with such problems on a regular basis. Using data analytics, manufacturing sectors can discover new cost-saving and revenue opportunities. The fourth application is related to the banking sector. Banking and financial institutions collect vast volumes of structured and unstructured data to derive analytical insights and make sound financial decisions. Using analytics, they can find out probable loan defaulters, customer churn-out rate, and detect fraudulent transactions immediately. The final application is based on logistics. Logistics companies use data analytics to develop new business models that can ease their business and improve productivity. They can optimize routes to ensure delivery reaches on time in a cost-efficient manner. They also focus on improving order processing capabilities as well as performance management. With that, now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart.
A study from New Vantage Partners suggests 97.2% of companies are now investing in data and its analysis. Nowadays, every company needs a data expert. Do you also want to become a part of this market? If yes, how to become a part of it? What are the essential skills one should have? This video will answer all these questions. But before watching this video, please subscribe to Simplilearn's YouTube channel and press the bell icon to never miss any updates. First of all, we are going to discuss who is a data analyst, working of a data analyst, skills required to become a data analyst, tools required, and companies hiring. And finally, we are going to discuss about salary of a data analyst. Let me tell you how Simplilearn can help you in your journey to become a data analyst. Check out the course on data analytics in collaboration with IBM with real-time project and business case studies. You will learn tools like SciPy, Pandas, and programming languages like Python or R too. Enroll now. Link is in the description box below. Question for you. Which one of the following is not a Python library for visualization? Matplotlib, SciPy, Pandas, Jupyter Notebook. Please leave the answer in the comment section below. Moving on, who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualization tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one's mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many cells per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future. Gear up for how many employees we need, how much money we're going to make. And prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst. And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel. So, they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as SUMIFs and COUNTIFs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel Power Query and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as Power BI, Tableau, and ClickView. Using these tools, data analysts can integrate various data sets, apply joint conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, they also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes, so they need to clearly translate their findings and insights into non-technical terms. So, those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now, let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517, while in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with
The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner on KNIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. 9 allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. 9 Server automates workflow execution and supports team-based collaboration. 9 integrates various other open source projects such as machine learning algorithms from Beca, H2O, Keras, Spark, and our project. 9 allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for 9 are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have 9. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed datasets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With QlikView, you can analyze data and use your data discoveries to support decision making. QlikView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of QlikView looks like. Now talking about its features. QlikView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the QlikView software helps the user by suggesting possible interpretations. QlikView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. QlikView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. QlikView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in QlikView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop, and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple datasets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools.
R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows, and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial, and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. A recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language. Next question was, which one of the following is a Python file extension? It was an easy question. Answer for that question is .py. Simplilearn offers you with the best courses for both Python and R. Certification offered by Simplilearn regarding R is Data Science with R certification course. It is a skill-up course that contains 64 hours of applied training, 10 real-life industry projects, dedicated mentoring session from industry experts, and finally, lifetime access to self-paced learning. I will provide the link for this course in the description below. Data Scientist for Python. It is a best course for a beginner. It includes 5 courses in collaboration with IBM at an affordable price. Courses includes Python for Data Science. After that, we will be covering Applied Data Science with Python, Machine Learning, as well as Tableau Learning, and Data Science Capstone. And finally, receive a master's certificate with individual certification for each course. I will provide the link for this course in the description below.
Want to be a certified data expert? Then here we have postgraduate program in data analytics by Simplilearn. Take a glance at the notable features and skills offered in this course. You will benefit from exclusive IBM hackathons and Ask Me Anything sessions, 8 times more interaction in live online classes with industry experts, capstone projects across 3 domains, and over 14 data analytics projects using real data sets from Google Play Store, Lyft, World Bank, and more. Masterclasses from Purdue faculty and IBM experts, along with Simplilearn's Job Assist for better job prospects. Acquire skills in data analytics, statistical analysis using Excel, data analysis using Python and R, and data visualization using Tableau and Power BI. Enroll now using the course link in the description box.
Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark under the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers, because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as an Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm's really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So With Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff, and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1. And it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running. It's still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type. And then we want, what is the type of array1? And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a 1-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2. And we have 0, 1, 2. 2 equals 3. We can easily change that. So we have array 1 of place 2. equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, two-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension, we'll do 1, 2, 3. And our second dimension, 3, 4, 5. And you can see right here that when we hit the, we'll do this, we'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. Two-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3, nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2, 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1, 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here. Whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do a range 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random.random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that. And you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part. And we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's the array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which would generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645, and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis, and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And see, this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is a column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows. And if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value, or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array. And there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. And we run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning because that's why it registers as 0, just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1. And when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing. 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge 2 arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that your whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back, and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up in my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing np unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and. if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And the last, one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in Pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this Pandas and PyPlot. So Pandas PyPlot, just so we can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import Pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how Pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with Pandas, so a lot of times you just import them by default. Seaborn sits on top of the Matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the Matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have Matplot library as PyPlot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand Matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the Matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we, of course, have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick, where we have car equals pd.read_csv, and then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it. And we're just going to do car head, because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go ahead and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make, model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in .values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. You know, it'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or sns.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small numbers, says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process, but right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. You know, we were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like a lengthy, here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit, so that when it prints out, instead of splitting it on two lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there. So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function dot sum. We end up with HP, the horsepower at 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we've cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps. And there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, fig size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's configuration, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones were put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that pyplot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our pyplot. So keep in mind that our pyplot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's learn about data manipulation in R. And here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R dataset, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function. And this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable and then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use and, or we can use or operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights, and in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA, and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights, overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights, average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this. And that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information, which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now, let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder and your horsepower and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column. And then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this. And let's look at the value of this one, where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column. You can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head, and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done. and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values, and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use df, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say b, which is going to get a sample out of a, and I just want 5 random values. So let's look at that. So we have b, which is going to get a set of 5 values from a. Now I will create a result variable which will arrange b, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default ascending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on one or two or multiple columns. And you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data, let's look at this one. And if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say control shift m, which is for piping. And then basically what you can do is you can do a select, and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select, where I can look at the new data frame. So let's do this. And I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder, and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4, or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation. So we will learn about functions and formulas. We will learn about conditional formatting, data validation, pivot chart, and pivot table. Now let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the questions is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, so Excel, or you might have heard as spreadsheet, can be basically used for a lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed. And here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour, and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Query. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your Alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here. So that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option, I can click on home and I can go for something like auto sum. So that's one more way of doing it, which anyways says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100, so I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here. And I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a Control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data in, say, one particular column, and we would want to derive the values out of it. So we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs, and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in, say, Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name. Go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in Control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking Control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say OK. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, if your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your X and Y axis, or as I would say in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is, once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is you can do a special paste or paste special. So under your home you have the paste option, and here you can go for paste special. And once you do that, you need to select the transpose option over here and click on OK. And now you will see that the columns and the rows have been transposed. So your row name was item and that has become the column heading. You had row name as amount and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again that's using your formulas. So what you can do is you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is, we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar, and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see, all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we go into sort and filter and say this is the data I have, say for example, I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted, but it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row if we sort it in an alphabetical order, which goes with bakery as desserts. You have the values, so we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just in changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words, so it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting, what is the sorting needs to be done, is it cell values, is it cell color, font color, conditional formatting, and then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date. So there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose. I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here. I could say okay, and now I have applied the filter. Similarly, you can select this, and then you can just clear your filter and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables, or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one. I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, so 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column, and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, and then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now say for example you have this data which has the values in the food column and department is empty, and say for example you would want to enter the values in department, however you would want to select the department should either have produce or meat and bakery, and these are the only 3 options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Ctrl D. So what I can do is under my department here, I can select one of the cells, and then I can do a Ctrl T. That basically converts this into a table. I can say OK, and my table is created. Now what I can do is once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values. So we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says, is the file delimited? I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet? You can also say add this to a data model if you are doing some data modeling. So click on OK, and now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here You can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web. And here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now, once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now, once we do this, it will basically get the data from web and put in here. It says existing worksheet. So we had already created a new worksheet. So let's click on OK. And now you have the data coming in. But then this basically shows me in one particular field. So what we can also do is we can just do a Control A that selects all my columns here. And that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for. And we can basically connect to a database. For example, if I have some database and say for example access database, I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources, which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say OK. And now if you see, the date has been sorted. So we have your 10/18/2007 on the top. So that seems to be the latest date. And as we go down, we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right and we could do it, or I could just say sort Z to A and then it has arranged the data based on the agent column being in descending order. Now I can go into area and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending. And that basically not only changes the order of this particular column but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say S dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say OK, and then say OK here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly, you have in the 12th row something like lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task of what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say okay, and then say okay. So now you see that the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter, and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter, where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and or condition. Now say for example this is the data I have, and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have three regions. So I'm only interested in central and South County, so I can get rid of North County, and that's fine. But then we have two different conditions here. So we need the data in central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County. So basically I can either just select this and I can choose this value, and then I can select this and then I can choose central. So that's the criteria which I have, and the pool value has to be, so central region should be with pool. So then this one basically has to be true, and this one has to be basically false. So South County is without pool. So let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data. So A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here. So that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy 2, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on 2 columns and then we have our result. So in this way you can have your customized filter applied on 2 different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in 2 different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county, area having 2 and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family. And here the criteria is that we would want to only populate these columns, which is agent, area, bedroom, and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms, and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet, and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type, I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data filter advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1 V2, which we have given here, and copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price. So I can select this. I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. Or let me do a Control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between my this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000, so I am saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem. And here we would want to use Excel, where we would have an AND and OR condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if, for example, here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a Control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3. And then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters. And all this advanced filtering, what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions, and you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal, so you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this returns the current date and time formatted as a date and time. So this is the function which we would want to use. And if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example, I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or SUMIFs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I placed my cursor here and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data, and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here and let's start with SUMIF. Now when I say SUMIF, it shows me there is a function with SUMIF which we would want to use. And here, once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has, well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data, so you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for some if, we can open the bracket. Now it needs the range, so we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using some if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now when we are answering this question, we can also look at the order in which things have been asked in the question. So it says what is the total revenue generated from central region. So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs. And when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just give in our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column. And let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with some ifs. Now we know that you start with some ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's see, let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now, remember, you can answer these questions using filters, and that can be an easier way, but then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name, say, Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a COUNTIF that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil. and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now, what about this question? So which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with count if, then I need my filtering criteria, so that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the Boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, and this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows, and then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019, and then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44, and here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this, and if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being East, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you are saying the region has to be East. So we would want to find out the total number of orders. So my region is East, and that gives me the result. Now similarly, you can also find out how many times Gil sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil, and then we are looking for sales rep, which is Gil, so that is my column C. So let's say C2 to C44, and the value should be just Gil. So it tells me it's twice where Gil has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gil. Okay, and now we are interested only in the item being pencil, so I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting, you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say, for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data, and what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a Control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green, and if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red, you have mid values, and then you have the positive value. So this is a 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below, we'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this and then I could basically choose my area, just hit on enter, and similarly you can go in here and then select your area, hit on enter and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example I'll go for blue and I'll say okay. So now if you see, my top 10 values are blue. Now similarly I can add one more rule. So I can say new rule and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say okay, say okay, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color and that takes care of the things. You can say for example select this, and now this is selected, but I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color, you have no border, this is basically color is black. Now I can go for something like gradient fill and I can say okay. And now if I say apply and okay, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color. I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar. I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values, if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts or people who are working in business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis.
In this video, we will learn some of the important features and functionalities of Power Query in Excel. Also, we will be doing an extensive hands-on demonstration using various datasets. So if you want the datasets and the demo files, then please put your email IDs in the comment section of the video. Our team will send you the files over email. Let's begin. So what is Excel Power Query? Power Query is an advanced feature of Microsoft Excel that allows you to prepare your data for analysis. You can perform numerous text computations and numerical analysis to make your data more powerful and informative. Excel Power Query is a data preparation and transformation engine. It allows you to carry out the extract, transform, and load operations on the datasets from multiple sources. Now, let's look at the challenges solved by Power Query. Earlier, in Excel there was difficulty in data connections. Now, using Power Query, you can connect to a broad range of data sources such as relational databases, web files, text, CSV, JSON files, and even fetch data in the cloud. Volume, variety, and velocity are the characteristics that define big data. It was a major problem to handle such data. Now, Power Query enables you to transform your data to an appropriate size. It also allows you to work on any shape of data from any source. Earlier, updating your data and refreshing it in real time was an issue. Using Power Query, a repeatable process query is adopted to update the data in real time and in the future. In Excel, it was not so easy to reshape, transform, and manipulate data, but using Power Query provides a highly interactive experience and sophisticated tools to prepare your data. Now, from Excel 2016 onwards, Power Query on Windows has been fully integrated into Excel. But in Excel 2010 and 2013 for Windows, Power Query is a free add-in. You can go ahead and download the link. Once installed, the Power Query tab will be visible in the Excel ribbon. Now coming to the features of Power Query. So Excel Power Query allows you to clean, transform, manipulate, and process your data for analysis. It helps you to automate repetitive tasks that you want to do it over and over again. You can search for data sources and make connections as and when you want. Power Query helps you to prepare and shape the data in the right format for performing analysis. And finally, once your data is ready, you can share your findings or use your query to create interactive reports and dashboards. Now let's have a glance at the demo that we are going to work on in this video. So we'll look at how to load data from different sources. You will understand how to extract tables from web files, so we'll extract tables present on Wikipedia pages. Then you'll learn how to sort and filter data. Up next, you'll see how to group your data, how to split a column into multiple columns, and then pivot and unpivot your table. Then you're going to work on date columns and make some transformations. Understand how to append tables and merge tables vertically and horizontally. Now let's open MS Excel and start with importing a simple text file. So you can see here I have my Excel file opened, and in the middle you can see I have my employee.txt file. Now this is a comma separated file, meaning that the values are separated by commas, as you can see it here. The columns have been separated by commas and all the values have a comma between them. Now this text file has information about the name, age, company, and the city to which the employee belongs to. Let's see how easily you can import this EMP text file into MS Excel. Here I'm using Excel 365 or Office 365, where Power Query on Windows has been fully integrated into this version of Excel. So what I'll do is, first let's go to the Data tab, and you have this section called Get and Transform Data. So I'll click on Get Data. Under Get Data, I'll go to From File and select From Text/CSV. Once I click on it, it will ask me to give the location where the file is there. So my file is on desktop. I'll click on Power Query Files, and here you can see I have my employee.txt file. You can see the type here, it says text document. Click on EMP and hit import. Now this will take some time to import the file onto Excel. It's establishing a connection, you can see. There you go. So here you can see the file name emp.txt. You can see the file origin. As I said, the delimiter is comma, and we have the data type detection. And here you can see we have our text file. So Excel Power Query feature has automatically detected the column names. So we have name, age, company, and city as our columns, and these are the values. Now let's hit load. So this will load all the rows and the columns onto Excel. There you go. It was really quick. Excel has automatically loaded our text file. Now you can see here we have another tab called Queries and Connections. So we have made one query and have loaded the employee data. It gives a preview also, you can see it here. And if needed later, you can go to edit and change some values that we'll see later. Now you can use this data to create simple visualizations. So let me show you how to do it. So let's first select the data and we'll go to the Insert tab. Under Insert tab, I'll click on Recommended Charts. Let's say I want to know how many employees belong to a particular city. So I'll click on the second chart which says the count of name by city, and I'll click on OK. Here you can see we have a nice clustered bar chart, and you can see in Bangalore there were 5 employees, in Hyderabad we had 2, and in Nasik we had 1. You can see the count here. This is a pivot table. If we go back to our actual data, here you can see in Bangalore we had Vidya, Sonam, Avinash, Varun and Himani, and there were 2 more people from Hyderabad and 1 from Nasik. So you can use the Excel Power Query feature to import data onto Excel and make some visualizations. Now, if you want to fetch some data that is present on the web or on the internet Excel Power Query features and functionalities can help you import those data as well. We will now see how to import data, specifically a table that is present on the web. Here, I'll be using a Wikipedia article on the list of European Cup and UEFA Champions League finals. Let me show you the page first. So this is my Wikipedia page on the list of European Cup and UEFA Champions League finals. If I scroll down, you can see all the details here. And I would like to import this table, which has the list of all the finals. So we have columns like season, winners, scoreline, runners-up, venue, and attendance. Let's import this table onto Excel. So I'll copy this URL first. Now let me open a new sheet. I'll go to sheet 1, and then on the data tab, under the get data section, I'll go to from other sources, and here I have from web, which allows me to import data from the web. Either you can follow this path, or if you see here, there's an option to get data from the web. If I click on this, it is asking me to enter the URL. So I'll paste the URL of the Wikipedia page here, and let's click on OK. Now it's navigating, and OK. You can see Power Query feature in Excel has given us a list of tables, which you can see here. We have something called as document. There's a key table, and here you can see there's one table which was extracted from the Wikipedia page, and the table which I am interested in is this table, which has the list of European Cup finals. You can see it here. Excel Power Query feature has automatically detected these rows, and it has given a list of columns as well. You can see these are the columns. Now we'll explore the transform data tab present in the Power Query. Now if I click on transform data, it will take me to the Power Query editor. Let me just click on refresh. Now this is the most important section. Now using the Power Query editor, you can clean your data, filter your data, manipulate your data, and make it ready for analysis. Now let's explore a few tabs available here. So we have a home tab that has a query section. You can see you can reduce rows, manage columns, sort the data, transform the data, combine different tables. Now there's another tab called transform, which allows you to select your data type, transpose your rows and columns, pivot and unpivot your columns, and here you can see you can find out some summary statistics, and you can manage your date values as well. Now if you want to add some new columns to your data, you can do that as well, and you also have a view tab. Now here, if you see the first two rows, the values are the same. You can see season, these are all repeated, which we actually don't need, and these are pretty similar to our column names. Similarly, if I scroll down, you see there are some rows which have null values. So actually these rows do not add up any value or do not add any value to our data. So we'll clean this data first. So let's see how to do it. Now if you want to remove certain rows in the table, what you can do is go to the home tab, and under reduce rows, click on remove rows, and then choose remove top rows. If I select remove top rows, it will ask me how many rows do you want to remove from the top. You can see it here. I want to remove the top 2 rows. Now let's click on OK. You will see that the Excel Power Query editor has removed the first 2 rows, and on the right you can see the steps that were applied. You can see it here. Previously we had these 2 rows which were redundant, and once we applied this step, it has removed the first 2 rows. Similarly, let's go down and remove the last 1, 2, 3, 4, 5. So we are going to remove the last 7 rows from the table. So again, I'll go to reduce rows and click on remove rows. Now this time I'll select remove bottom rows, and here I'll choose I want to delete 7 rows from the table from the bottom. I click on OK. If you see, the last 7 rows have been deleted. Now let me show you the last row, which is this one. So the last season of UEFA Champions League was held in 2020, which is this year, and Bayern Munich won the Champions League against a French team that was Paris Saint-Germain by a score of 1-0. Now if you see the last value, that is the attendance, you can see the value is 0, which means there were no spectators in the stadium. It was because of the COVID conditions. Now let's do some more manipulation to our data. Suppose this time I want to add a new column, let's say a stadium name, by extracting values from the venue column. So let me just show you the venue column. So this is our venue column. So the first value is the stadium name. Then we have the city in which the stadium is there. And finally we have the country name. So I want to extract only the stadium name. So you can see we have some stadiums like Santiago Bernabeu, there's Wembley, San Siro, and other stadiums. So I want to extract only the stadium names. So let's see how to do that. I'll click on the venue column and go to Add Column tab. Under Add Column, here you can see we have Extract. Now if I click on this drop down, there is an option to select Text Before Delimiter. So if I choose Text Before Delimiter, here I'll give my delimiter as comma. So everything before the first comma will be considered as the stadium name. Now let me click on OK. Now here you can see under applied steps it says inserted text before delimiter. If I scroll to the right, you can see the last column has our stadium names. Let me double click on this and change this to stadium name column and hit enter. Even this step is applied here. You can see renamed columns. Similarly, let's explore a few more features. Now I want to add a new column called Stadium City. So if you consider this venue column, whatever is there between the two commas is the stadium city. So for example, Santiago Bernabeu is in Madrid. Similarly, Wembley Stadium is in London. San Siro is in Milan. So these middle values I want to extract into a new column called as Stadium City. So let's see how to do it. So I'll click on the venue column and go to Extract, and again I'll select the Extract tab, and here now I'll choose Text Between Delimiters, and my first delimiter I'll give is a comma and a space. You can see here all the values have a comma and a space, and my end delimiter will be another comma. Then I'll click on OK. This will add a new column to the extreme right of the table. You can see here we have text between delimiters, and it has extracted the stadium city. Let me go ahead and rename this column as Stadium City and hit enter. You can see the applied step here. Now I want to split the score column into two columns. So here we have the score column, and the left value presents the number of goals that were scored by the winning team, and the right value presents the number of goals that were scored by the losing team. So here I'll split the column into two columns as winner score and loser score. So what I'll do is select this column and go to the Home tab. Under the Home tab we have split column. I'll select split column and then choose byte delimiter. So automatically Excel Power Query detects that this dash is my delimiter, and I'll split at each occurrence of the delimiter. Let's click on OK. Now you can see the score column has been split into two. It has renamed the column as score.1 and score.2. What I'll do is I'll go ahead and we'll rename this column as winner score, and this will rename it to loser score. I'll hit enter and I have renamed it successfully. Next, let's change the winners team and the runners up team values to uppercase. So suppose I want to change all the values or the club names of the winners team to uppercase. So what I can do is I'll select this column and go to the transform tab. Under transform tab I have this option called format. So here I'll click on format, and then you can see I can change the case to lowercase, uppercase, capitalize each word. So here I want to make all the winner teams as uppercase. I'll select uppercase. There you go. We have successfully converted all the winner team names to uppercase. Similarly, let's do it for the runners up team as well. So here I have my runners up team. I'll go to the transform tab, click on format and select uppercase. Now we saw how to do some simple manipulation of our data. So we created a few columns, split a few columns. Now to save all this, I have to go to the home tab and then click on close and load. This will take some time and load our data onto this Excel sheet. You can see here it's loading the data. This will take a bit of time. There you go. Excel Power Query feature has successfully performed some manipulations on our data, some calculations on our data, and then it has saved the final version and loaded it onto Excel. Now using this clean data, we can do some analysis. Let's say I want to find the seasons in which the winners team scored more than 3 goals. So we have a problem statement at hand where we want to find the seasons in which the winner team had more than 3 goals scored. So what you can do is select any cell in this data and go to the insert tab and click on pivot table. Here I'll click on existing worksheet and then I'll give my location. I'll place my pivot table somewhere here and click on OK. Alright, now since I want to know the seasons, I'll drag season onto row, and I'll also drag the winners team column onto rows. Then I'll choose my winner score under values. Here you can see we have the pivot table ready. Now we need to filter this table to see all the winning teams that scored more than 3 goals. So what I'll do is I'll select this winner score column and place it under filters. And here you can see I have my filter. Let me click on this drop down and I'll select multiple items. From this multiple items I'll choose 4, 5 and 7 because these values are greater than 3 and click on OK. Here you can see I have filtered my pivot table, and to the left you can see the season and the winner team that had scored more than 3 goals in the finals. Alright, similarly you can perform some more analysis. Suppose I want to know how many times Real Madrid won the championship. So let's see. I'll click on one cell in the dataset, go to the insert tab and click on pivot table. I'll choose existing worksheet and give my location here. Let's say I want to place my pivot table here. I click on OK. Alright. So the question we have is how many times have Real Madrid won the championship? So I'll choose the winners team column and place it under rows, and let's say we'll select the winner score as well, and let's convert this winner score from sum to, let's say, count, and click on OK. And since I want to check only for Real Madrid, so what I'll do is I'll go to the insert tab and I'll insert a slicer. Here I'll choose winner teams as my slicer and click on OK. And out of this I want to choose only Real Madrid, so I'll select Real Madrid. You can see it here. Real Madrid have won the championship 13 times. Okay, let's say you want to compress your data and remove unnecessary columns without losing any information. You can do that using a feature in the Power Query editor called unpivot. To perform this task, we'll use a census data of India from Wikipedia. So let me first show you the Wikipedia page. So this is my Wikipedia article which says list of states in India by past population. And if I scroll down, you can see it here. There's a table which says by past population from 1947 to 2011. So there are a few columns like rank, this state or union territory, and we have population starting from 1951 till 2011, which was our last census. Here you can see if I scroll further, there are nearly 29 states and we have 7 union territories. So we will extract this table and load into Excel first. Okay, so let me click on a new sheet and we'll follow the same drill. I'll go to my data tab and click on get data. Under get data I'll go to from other sources and click on from web. Here it will ask me to provide the URL link of the Wikipedia page, so I'll paste the URL here and click on OK. Now once I have done that, it will load a few tables onto Excel. You can see there are a few tables here. I'll click on the first one. So we have our table here. Now let's do some transformation to this data. This opens in the Power Query editor. Okay, I'll click on refresh first. This will take some time to refresh the entire data. Okay, we are done. Now if you see this data clearly, the first row in this table is not necessary at all because these are our column names. So we also have our column headers already present. So let's go ahead and delete the first row. So we'll go to the Home tab. Under Remove Rows, I'll click on Remove Top Rows. Now I'll give my number of rows as 1. So we want to remove the first row only. I'll click on OK. You can see the first row has been deleted. If I scroll further, I actually don't need the last row as well, which is the total. So what we can do is we can also remove the last row from the bottom. So I'll select 1, click on OK. You can see the step has been applied and you don't see the last row that was the total row anymore. So the task that I want to do here is I want to compress all these columns, which are basically the population columns. So I'll select my state or union territory column and go to the transform tab, and here I have the option to unpivot columns. So I'll click on this drop down and select unpivot other columns. You can see here the step has been applied and all the population column from 1951 till 2011 have been unpivoted. If you want, you can go ahead and rename these columns. Let's say I'll write it as population column, and let's say this is, I'll rename it to total population value. Alright, now we are done with our preparation of data. Let's go to the Home tab and click on Close and Load. Now this will take some time to load the data onto Excel. Alright, so we have our census data here. So first you can see rank 1 is Uttar Pradesh, and we have the population starting from 1951 till 2011. Then we have for Maharashtra. If I scroll down, you can see the other states. We have Tamil Nadu, Rajasthan, there's Karnataka. If I scroll further, we have Odisha, there's Telangana, Kerala. Now if you see here, the population values from 1951 till 2011 for the Telangana state are all NA, which means there was no data available. Now this is because Telangana was only formed in 2014, so there was no census for this state. Let's continue with our demo and let's explore a few more features and functionalities of Power Query Editor. Now the next table we are going to use is an AdventureWorks customer table. Now this dataset is provided by Microsoft for practitioners who want to learn Power BI, Excel or similar technologies and want to do some manipulation, some calculation, some data analysis stuff. So let me go to a new sheet and let's import the AdventureWorks customer dataset. It's a CSV file onto Excel first. So I'll go to my data tab and click on get data. From here I'll go to from file and choose from text/CSV. You can see it here in my Power Query files folder. I have my AdventureWorks customer table. I'll select this and click on import. This will take some time to load the dataset. You can see the preview of the dataset here. So we have columns like the customer key, we have the prefix of the customer name, the first name, the last name of the customer, date of birth, marital status. If I go to the right, we have annual income, total children, education level, occupation and homeowner column as well. So let's click on transform data. Here we'll learn a few more features of Power Query. Okay, we have our data on our Power Query editor. So first what I'll show you is, let's change the prefix column, the first name column and the last name column to proper case. So you can see it here, the prefix, first name and last name columns are all in uppercase. Now if you want to change the values to proper case, just hit Ctrl and select the three columns and go to the transform tab. Under transform tab you have format. So if you click on format, here you can see we have lowercase, uppercase. Now proper case is to capitalize each word. So I'll click on capitalize each word. You can see it here now. We have converted the prefix, first name and last name column into prop case. The next step I'm going to show you is, let's merge all the three columns, the prefix column, the first name column and the last name column into one full name column. So what I'll do is I'll select the three columns and then let's go to add column, and under add column we have this option called merge columns. Let's hit merge columns. Okay, now it's asking you to give the separator. I'll select my separator as a space and click on OK. Okay, so before click on OK, I want to change my new column name from merged to, let's say, full name. And now let's click on OK. You can see here it says inserted merged column, and if I go to my right, you can see it here we have a full name column. Now if you want to shift the location of the full name column, you can do that as well. Just hold this and keep on dragging to the left. This will move the entire table to the right and you can place it wherever you want. So I want to place it, let's say, here. Okay. Now actually I don't want all these columns, so let's delete it. So click on this and I'll right click and click on remove. You can see we have removed the prefix column. Similarly, let's remove the other two columns. You can either right click and do, or go to the home tab and then select remove columns. Alright. Now let's say we want to add a domain name column from AWS customers by extracting the characters between @ and .com. So actually I'm talking about the email address. From this email address we want to create a new column called as domain name. For that we'll extract characters that are present between @ and .com. So let's see how to do it. I'll select the email address column and then I'll go to add column. Under add column I'll click on extract, and this time we want to extract between two delimiters. So I'll select text between delimiters and I'll give my starting delimiter as @ and my end delimiter would be .com. Now let's click on OK. So this will insert a new column to the extreme right. You can see we have our domain name. Let's go ahead and change the column name to domain name and hit enter. Alright, you can see the step has been applied. Now we are done with our preparation of customers table. Let's just go to the home tab and click on close and load. So all the transformation that we did in the Power Query editor will reflect here. So you can see we have our full name column, and if you see we have our domain name as well. Okay, now using the Power Query editor you can perform some statistical analysis. Now let's explore those statistical features. For this we'll be using another dataset called AdventureWorks product dataset. Again, this dataset is also provided by Microsoft. So let's go to the new sheet, and here I'll go to the data tab, click on get data. Under from files I click on text/CSV. Here you can see we have AdventureWorks products. I click on import. Let's click on transform data. So we have our data loaded onto the Power Query editor. The data is mostly clean, so let's not alter this data. Let's straight away go ahead and explore some of the statistical features that we have here. Now let's say if you want to find the total number of product names in the product table. We have this product name column, and say if you want to find the total number of product names in the table, how to do it? So what you can do is click on this product name column, then go to the transform tab. Now in the transform tab you have an option called statistics. Click on this drop down and select count values. Now this will open another window that will return the total number of products in the table. You can see the value here, it says 293. Now to move back to the query editor we have to cancel this step here. So let's just click cancel or close. We are back again. Alright. Now let's say you want to calculate the average product price from the product table. So if I move to the right, you have a column called product price. So let's see what is the average product price from the product table. So I'll select this product price column, go to the transform tab. Under statistics I'll select average. So this will give me the average product price, which is 714.4373. You can consider any unit you want. Let's say this is in dollars. Now again we have to cancel this step to move back. Okay. Now if you want to find the maximum and minimum product price, you can do that as well. So let me select my column product price and go to the transform tab. Under the transform tab we'll click on this statistic drop down, and let's say I'll select minimum. So this will give me the minimum product price, which is 2.29. Similarly, if you want to find the maximum product price, so select this product price column, go to the transform tab and then choose maximum. So this is the maximum product price in the product table we have. Let's cancel this step. Okay. Now you can also round the product cost and product price column to 2 decimal places. So if I show you both the columns, you have your product cost and you have the product price column. You can see the floating values or the decimal points are not constant, it's varying. So let's limit it to 2 decimal places. What you can do is select both the columns and then go to the transform tab. In the transform tab, you have here rounding. I'll click on this drop down and select round. Now here I'll give my decimal places as 2. If I click on OK, you can see here both the columns, the product cost and the product price column, have been rounded up to 2 decimal places. I can scroll down, you can see all the values have been rounded up to 2 decimal places. Alright. Now let's say you want to add a column called discount price column by multiplying 0.9 to the product price column. And let's say you also want to round that new column to 2 decimal places. So how to do it? So we want to give a discount of 10%. So I'll select this product price column, go to add column, and then I'll choose custom column. Here we'll write a formula. So I'll give my new column name as discount price, and my formula would be, I'll select product price, I'll click on insert, and then I'll multiply this product price by 0.9. So this will give me my 10% discount on the product price, and click on OK. You see here we have our new column added, which is discount price. So if the product price is 34.99, if you give a 10% discount, it's 31.491. Alright. Now the next question was to change the or round the decimal places to 2. So I'll go to the transform tab. Under rounding, I'll click on round. Let's say I'll give 2 and click on OK. So even this has rounded the discount price column to 2 decimal places. Now we are done with our mathematical operation on this product data set. So we saw how to find sum, average, count, how to round up values, how to add a new custom column. So let's go ahead and close it and load it onto Excel. You see here we have our new product table added here, and the last column, if you see, it's the discount column that we added. Okay, now it's time for us to explore another feature. So we'll use a table called AdventureWorks calendar table, which has basically a date column, and let's see how using Power Query you can prepare that data as well and make some manipulations, some calculations. So let me go ahead and import AdventureWorks calendars table. Again, this dataset is provided by Microsoft. So I'll go to my new sheet and I'll go to the data tab, click on get data, and from here I'll click on from text/CSV, and you can see I have my calendar table here. I click on import. Now this will open in the query editor. You see here this dataset has only one column, which is a date column. So let's click on transform data. Okay, now if you see here, the first row is actually the column name. So let's do the transformation here. Let's push this as the column name. So I'll go to the home tab, and under home tab you have this option called use first row as headers. I'll select this. You see here we have the column name as date. Now before making any operation, let's see if all the fields are available. You see here, if I click on the date drop down, the year, month, quarter, weekday, day, everything has been shaded out and I can't access this. The reason is the date settings are not correct. So we'll change the regional settings. Let me show you how to do it. So we'll go to File and I'll select Options and Settings and go to Query Options. Under Query Options, we have something called as Regional Settings. Here, under Regional Settings, we'll select English United States instead of English India. So I'll just scroll down and here we have English United States and I click on OK. Now once this is done, I'll go to my data type and I'll select date as my data type. I'll choose replace current. OK. Now you can see my date column has been formatted. If I go to the date tab, you can see I have access to all this. Now let's do some operations on this date column. Let's say you want to find the earliest and the latest date from AW calendars table or the AdventureWorks calendar table. So what you can do is select this column, go to date drop down under transform, and here we have the option of earliest and latest. So if I click on earliest, this will show you the last date, which was 1st of January 2015. Let me close this. Similarly, you can see the most recent date. I'll go to the date drop down and click on latest, and you have 30 June 2017 as the latest date. I'll close this. Now let's add a new column, say day name, start of the week and others. So I'll select my date column, go to add column. Here under add column, I have my option to select the day name, the week name and others. So I'll click on this date drop down and under day, let's say I want to choose name of day. This returns the day name. Similarly, let's say I'll want to find out the start of the week. You can see we have the start of the week column or start of week column. Now one thing to notice here is in this Power Query editor, the week starts on a Sunday. Now suppose you want to start your week on a Monday, you can do some transformations on this formula tab. So here in the formula bar, you can add a 1 here to make sure your week starts on a Monday. So if I hit enter, you will see all these values will change. You can see it's 28, 4 and 11. This will become 29, 5 and 12. Let's hit enter. You can see it here. Your start of the week is on a Monday. Now there's another method to make sure your week starts on a Monday. Let's cancel this step. Okay, I have to insert it once again. So I'll go to date and here I'll choose start of week. Now the week starts on a Sunday. So one more method is to add day dot Monday. You can see automatically Power Query is giving me a suggestion. So I'll hit tab to finish it and I'll hit enter. Now you can see the values have changed and our week starts on a Monday. Now let's say we want to add a few more columns like start of month, name of month, start of year and the year value. So you can just click on the date column or select the date column, go to the transform tab. Okay, not the transform tab, let's go to the add column tab and here let's say I'll choose year. So we have all the year values and similarly let's say I want to know the start of the year. Now you can do a few more transformations. Let's say I want to know the month. Now here it gives us 1, which means January, that's February, March and so on and so forth. Let's say we'll do one more. I'll click on this, go to my date drop down and here I'll choose, let's say I want to know the day of year. Alright, Now we are done with all our transformation and preparing our data on a date field. So let me just go to the home tab. I'll click on close and load. Now this will load the dataset onto Excel. You can see it here. We have the data ready. Now you can use this data to make some analysis, draw a pivot table, draw a pivot chart, and do a whole lot of things. Now while working on a project, it is possible that not all your data will be in a single file. It could be stored in multiple files. So it's important to combine and bring all your data together. Now we will see how to join your data vertically. I have my data present in a CSV folder. So let me show you the folder first. So this is my CSV folder. Let me open it. And I have some files. These are named as project 1, 2, 3, 4 and 5. Let me open just one of the project files. It has a very small quantity of data. You can see it has a month column and an amount column. Let me close this and let me show it to you again. Let's open project 4. All the files have the same number of columns. You can see this also has a month column and an amount column. Now we'll combine all this data together and load it into Excel. Let's see how to do it. So I'll open a new sheet and I'll go to my data tab and click on get data. Then I'll go to from file and this time I'll choose from folder. Now this will ask me to give the folder location or the path location where my CSV files are. So I'll choose browse and here you can see I have my CSV file. I'll just double click on it and click on open. Now it has selected my file path or the folder path. Then I'll click on OK. You can see these are the files. You have project1.xls, project2.xls and so on. I'll click on this combine drop down and I'll hit combine and transform. Now this will give you the preview of one of the data files. You will see it now. You can see it here. It says sheet 1. Okay. Now it's processing all the data files present in that CSV folder. And this will be uploaded onto our Power Query editor. Now you can see here on the Power Query editor, all my data files have been combined vertically. Here you can see the month column. On the extreme right, it's the amount column. And to the extreme left, we have the source name or the source file where the data came from. So first is project 1, then we have project 2. If I scroll down, we have project 3 files, project 4, and similarly we have project 5. Now this is one way in which you can merge your tables vertically. So we are done with it. Let's just go to the home tab and click on close and load. All the transformations that were applied, you can see it here. We have our final table and we have successfully combined 5 Excel files. Again, you can also join your data horizontally. This would be like an SQL join where the data is present in multiple files or sheets. Based on a common key column, you can join the tables. So you can perform a left join, a right join, an inner join based on the problem that you are trying to solve. So let's merge two tables based on a column. I'll show the dataset first. It's an Excel file which has 3 worksheets. So here is my Excel file which we'll be using to merge our data horizontally. You can see there are 3 worksheets. The first one is year 11, which has data regarding the student name, the gender of the student, and the course the student had opted for. Similarly, we have another for 2012 or year 12. We have the student name, gender, as well as the course. And finally, we have a courses table or a courses sheet, which has all the details regarding the course. So we have the course name, the teacher who teaches or teacher who taught that course. We have the lesson type, the number of credits, and the assignment type. Now we'll use this datasets to load it onto Excel using Power Query. So I am on my Excel sheet. Let's just open a new sheet. I'll go to the Data tab, and here I'll click on Get Data, and this time I'll choose from Excel Workbook, and I'll select my file, which is Students and Courses. I'll click on Import. So we'll just see how to import two tables and join them horizontally. So let me first select the Courses sheet, and I'll click on Transform Data. Now this has loaded the courses table onto Power Query Editor. The table looks fine. We have the course column, teacher, everything is fine. Now let's load one more table and then we'll merge it. So here under the Home tab you have a section called New Source. I'll click on File. I'll again select my Students and Courses and click on Import. And this time let's choose another table, let's say year 11, which has the column name as student, gender and course. I click on OK. Now it has successfully loaded this table onto Power Query Editor. Now if you say this, the first row is actually our column names. So I'll go to the Home tab and select Use First Row as Headers. So this will push the first row to the column names. You can see we have done it successfully. We have my student name, the gender column and the course column. Now let's merge it. So if you see here in the Home tab we have a section called Merge Queries. Let's click on this drop down and select Merge Queries. Here I have my table which is year 11, and let's choose one more table, that is courses. Now the kind of join I'll choose as left outer join, which means it will take all the rows from the first table and matching records from the second table. Here I need to select the common key column. So if you see both the tables, we have the course column as the common key column. So I'll select this, and now you can see there's a tick mark, which means it has selected the rows and the columns successfully. You can see it says the selection matches 175 or 175 rows from the first table. And let's click on OK. Let's just expand this and click on OK. If I scroll to the right, you can see I have successfully merged both the tables. Now if you want, you can remove unnecessary rows or columns. Suppose if you see I have the course column from the year 11 table, and here also I have the course column. Now this is redundant. Let's just remove one of the columns. I'll just select this column. I'll go to remove columns and I'll select remove columns. Okay, the rest looks fine. We have successfully merged both the tables by using a left outer join. Let's just click close and load. Now this will take some time to load our data onto Excel. You can see it here. We have successfully loaded it onto Excel. Now we are done with our demo part. Now let's just see what all we have done in our demo. So I'll go to my first sheet. Here you can see we had imported a simple text file first, and then we plotted a graph which is a pivot chart. Then you saw how to upload a file from the web. So here we imported a UEFA Champions League table which was present on Wikipedia, and then we plotted some graphs and charts. You can see we made some analysis using pivot tables, and then we imported another web file which was based on a population data, and we used the unpivot option or the unpivot feature in the Power Query to reduce the number of columns. Then we made some calculations to our customer table, which was from AdventureWorks. Then we used another table called the products table. Here we saw some statistical calculations, and we added a column called discount price where we used conditional operations. And then you saw how we manipulated a date column, and then we saw how to append and merge multiple tables.
I have a sample of data in my Excel to perform the Anova over. There is an amazing feature in Excel that many people are not even aware about. It's a data analysis tool pack. If you have not come across this word, the Data Analysis Tool Pack in Excel is an add-in that provides the advanced data analysis tools for statistical and engineering calculations. It simplifies the complex data analysis task by offering the built-in features to perform various statistical tests and data processing without needing to write formulas manually. So we need to ensure first if we have activated the tool pack correctly. So for that, we need to go to the File and then Options. And then we have to move to add-ins, and here in the Manage, you have to choose for the Excel add-ins and click on Go. After that, you need to click on this Analysis Tool Pack and click on OK. Now when you see the topmost bar, that is the data, if you click on this data, you will see a data analysis button over here. Now we are all set to perform the analysis of variance. To perform this, I will click on Data Analysis button, and from there I will choose Anova single factor and select on OK. Now here in the input range, we need to enter the range of the cells containing your data. For that, I will click on this upper arrow button and highlight my cells that are containing the data. The next option is grouped by, depicts how your data is arranged in your sheet. If it is arranged in a column like I have arranged, choose columns, and if it is arranged in a row, go for the rows. Now here in the labels in the first row, if you have labels like mine, like group A, group B and group C, do tick this button. Then alpha is generated, and here in the output options, this is where you want your result to be returned. The first option is the output range, is where you can specify a particular cell where you want your result to be returned. The second option will enter the answer in a new worksheet, and the third option will enter the result in a particularly new Excel file. I will choose the second option and will name it as Anova. Now we have got this result. Within just one click, you can definitely get the Anova single factor results. Now I will explain each factor, what it means, count, sum, average, variance, SSD, FMS, etc. in the next PPT. So the first table depicts a summary of the data available in the analysis. So the first one we have got is count. Count is the total number of data points in each group. Here, in group A, group B and group C, we have 14 data points. Now moving on, we have sum. Sum is the total value if we add up all the values in each group. So the sum of group A is 958, sum of group B is 1093 and sum of group C is 1280. Now moving on, we have average. Average is the sum divided by the total number of data points in each group. So the average of group A is 68.42, the average of group B is 78.07 and the average of group C is 91.42. Now, lastly we have variance. Variance is the average of the square differences from the mean. Now, the variance of group A is 141.34, the variance of group B is 209.60 and the variance of group C is 119.49. Now the second table here is divided into three groups, the between groups, within groups and total. So the first row depicts the result when the between rows are classed as a source of variation. The second row depicts when the source of variation is within the groups. And finally the last row is just the total. Now we will see what each column represents. So the first one we have is SS. SS stands for sum of squares. Between group SS is the total variation explained by the differences between the groups within group SS is actually the total variation within the groups due to the random error or individual variability. And the total SS is the sum of the between group SS and within group SS. So the between group SS over here is 3735.19, within group SS is 6115.78, and the total SS is 9850.97. Now moving on, we have DF. DF stands for degrees of freedom. This is calculated slightly differently. For between groups, DF is the number of groups present in your data minus 1. I have 3 groups, so 3 minus 1, I have got 2. To determine this, within groups, DF is the number of observations minus the number of groups, that is 42 minus 3, that is equal to 39. Then we have MS. MS stands for mean square. You can think it as the variance for each source of variation. To calculate this, we can simply divide the sum of squares by the degrees of freedom. Now moving on, we have F. F stands for F statistic. Here the F statistic is calculated as MS between the groups divided by the MS within the groups, and it is equal to 11.90954. Now moving on, we have the F critic. F critic stands for F critical value. It is calculated easily by Excel, or you can perform it manually by looking at the critical value table. So the F statistics is then compared with the F critical value. If the F statistical value is greater than the F critical value, we can conclude that the test is significant. Now moving on, we have the p-value. The probability of obtaining an F statistic as extreme as or more than the observed value assuming the null hypothesis is true. A small p-value that is less than 0.05 suggests that the significant differences between groups exist. As my p-value is more than the alpha level, that is the 0.05, we fail to reject the null hypothesis. Therefore, there is no difference between the means of the 3 groups.
Tableau is a very powerful and fastest growing data visualization tool used in the business intelligence industry. It helps in simplifying raw data into a very easily understandable format. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. So today we will learn Tableau through the following agenda. First, we will understand what exactly is business intelligence and what is the importance of business intelligence in real-time business. Followed by that, we will have a brief introduction of Tableau, and we will also learn how Tableau really helps in business. Next, I will guide you through the installation procedure, where I will help you to install Tableau into your local system. Once the Tableau is installed into your local system, we will have a brief tour about Tableau, the kind of worksheets you can work with, the kind of data it can import, the options provided in the Tableau, the kind of charts, everything. So once we have a better understanding of Tableau and the options provided in it, we will directly move into the worksheets, where we will work on the Excel data and try to create some worksheets. Once we are good with the worksheets, we will enter into the next segment, where we will understand how to create a real-time dashboard. I hope I made myself clear with the agenda. Now let's begin with our first topic, that is the business intelligence. So what exactly the business intelligence term mean? So to understand business intelligence in a much better way, let us imagine that you have started a business. So a business of online marketing, where you sell some phones, some products, and some other items which are necessary for your customers. So what would you do to best reach your customers? First, you will understand their needs and requirements. You will either try to mail your customer or try to contact your customer through a phone call, and you will understand what exactly he needs and what type of requirement he has. Just imagine that your customer needs a phone. You will understand his need and then try to call him and understand his requirements. For example, it may be an Android phone or it may be an Apple phone. So he will be having some requirements, certain size of RAM, certain size of ROM, and extended memory or operating system. So you'll basically understand his needs and requirements and try to provide him with the best product. So in this situation, if you provide him with the right and the best product, then you'll be having a good customer satisfaction and positive reviews. This customer satisfaction and reviews come under the sentimental analysis. These sentimental analysis and positive feedbacks and reviews from your customers will help you gain more customers. And in result, you will have a good market profit. So this is what exactly business intelligence means. So to make things easier in business intelligence, we have certain softwares: Tableau, SAP, SAS, Oracle, MicroStrategy, Qlik. These softwares are the segment leaders in market research and business intelligence. So today we will be learning about Tableau. So why Tableau? You might have that question in your head, right? So the answer for that is, according to Gartner, there are multiple business intelligence softwares like MicroStrategy, Best, Looker, Demo, IBM, Salesforce, Tableau, Microsoft, Qlik. But the best in the market leader in the ability to execute and completeness in the vision, Tableau is ranking in #1 position. Now we have understood what exactly business intelligence is and why Tableau is on the top. Now we will understand a brief introduction to Tableau. So Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize and make data-driven decisions in real time with extreme agility and accuracy. To better understand what exactly Tableau does, let us imagine that you're given some data in the form of Excel sheet that has thousands or even lakhs of rows and some hundreds of columns or even thousands of columns. And you had to kind of filter or kind of apply some operations on that and get some insights of that particular data. So basically, if you do it in a brute force method, it could be really time consuming. But what if there is a software that can write all the SQL queries possible on your data, and all the data you wanted is readily available, or all the information you ever wanted on your data is readily available just by a single click? Yes, exactly. That's what exactly Tableau does. It automatically writes all your SQL queries in the background, and it can provide you the information in the form of a variety of charts like the bar charts, pie charts, and it can even give you some live data and also the advices based on which you can move ahead and improve your business. Now let's go through some sample data and understand how it exactly does it. So on my screen you can see some Excel data which is based on some store in America. So here you'll be having different regions of America, that is South, North, East and West, and the category of furnitures, subcategory bookcase, and etc., which kind of category is selling most in which kind of region, and what's the discount, what's the quantity, and what's the profit, etc., in this particular Excel data. So you'll be using this particular Excel data to get some insights of this sales happening in America. So this is how business intelligence works basically. So here we should use the Microsoft Excel to get the necessary insights of this particular data. Now just select all these cells of this particular Excel and select insert, and on the left corner you can see pivot table. Select that, and here if you had an existing worksheet you can select the existing worksheet, or if you don't have that you can select the new worksheet option and then just press OK. Now we have our pivot table over here and we have our fields in the Excel data on the right side part. Now just select a region and push that into the columns, and now let's select sales and push that into the values. Now we have the sum of sales option, so we have the east zone, central zone, south zone, west zone, and the summation of sales happening in that particular section of America or region of America. Now we can also make some changes to the values, like we have summation, and we can select some value field settings, and inside that you can go through count, average, maximum, minimum, and select few more options based on which you have to calculate it. Now let's push the rows, or let's push the regions from columns to rows so that we can have some good data in a more understandable form of view. So there you go, you have the central region, east, south and west on the left side, and on the right side you have the summation of sales happening in that particular region and the grand total of the sales. Now let's try to do this in the Tableau. So there you go, your Tableau just got started. So on the left side you have got the connect option and the various types of files it supports, that is the Microsoft Excel, text file, JSON file, Microsoft Access, and more on that in the next upcoming part where we'll have a tour on that. Now let's select Excel. So we have already an Excel file on the downloads part. Just select that one and just open it. And there you go, you can see all the rows and columns here. Now let's go to our sheet. So on the screen you can see that on the left part we have the data which is connected to the Tableau, that is sheet 1, the store data, and these are the dimensions and these are the measures. So basically Tableau divides the data into dimensions and measures automatically, and you can see some options provided on the top row, which is the file, data, worksheet, dashboard, story, analysis, map, format, window, help, etc. And here you can see some marks, which is the color. So here you can just imagine that you worked on some bar data or bar chart, so that you can use color options to provide different colors to your bars. And you can also select the size of your bars, add some text if you wanted to add in, and you can add some details if you wanted, and some tool tips, etc. And on the right side you can see show me option, and this particular tray helps you to get different types of charts you wanted to keep on your data. For example, you want to select pie chart, you can just select pie chart. If you wanted to go with bar chart, you can go with bar, and some area charts, and you can see maps, etc. And the best part is when you hover over this particular chart or any kind of selection you wanted to make, then Tableau automatically helps you for having the dimensions and measures for that particular chart. You can see in the bottom part where it is highlighted for pie charts, try 1 or more dimensions and 1 or 2 measures. So if you hover over the bar chart, you can see that Tableau tells you for side-by-side bar charts, try 1 or more dimensions and 1 or more measures. So basically it is telling you to have 1 or more dimensions or 1 or more measures in order to use the side-by-side bar charts. Now let's do the same thing what we did in Excel. So here we'll just select the region and pull that over the columns, and now we shall select the sales and push that over the rows, and there you go. You can see the bar chart over here, and it's automatically telling you the kind of sales happening in that particular region. Now you can even select the region part and drag that over to color so that it gives you different colors. Now if you see on the right side show me tab, you can see different types of charts available for your data. So you can have a pie chart, you can have the bar chart, you can have few more map charts, etc, etc. So that's how Tableau gives you automatically all the types of options that you can work on the data visualization by using different types of charts. So that's how Tableau basically works. Now we will go into the next step where I'll help you to install Tableau into your local system. Once the installation is done, we will get back to Tableau again and we will understand each and every part of Tableau in much more detail, and we'll also work on each and every type of chart present over here, and we'll work on multiple sheets, and finally we'll enter into the dashboard. So far so good. I hope you have understood the basic introduction to Tableau and basics of the Tableau fundamentals, how to use rows and columns, what are dimensions, what are measures, and what is show me, and how do you change colors of your bar charts over here, and you can highlight this. So we'll work on everything after we finish the installation process and get back to worksheets.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
So before we go any further on Tableau installation, let us understand the Tableau products first. So there are multiple types of Tableau products. So here we will be having Tableau's desktop, Tableau public, Tableau server, Tableau online, and Tableau reader. So let us understand Tableau desktop first. Tableau desktop is a paid desktop application. It is also called as Tableau Desktop Professional Edition. This is where the developers create charts, formula, dashboards, actions, and everything. It has a 14-day trial too. The dashboards we create here can be published on any server listed above. The data can also be opened from Tableau Reader. Moving ahead, we shall understand the Tableau Desktop. So for beginners, let me tell you, Tableau Desktop is like open source data. Whatever the data or whatever the sheets, whatever the dashboards you work on using Tableau Public will be available for public. So keep this as your reminder. And it is not preferable if you want to use Tableau for your company's confidential data, because it might go public and it might be risky. So Tableau Public Desktop is a free desktop application. It is the developer place for Tableau Public Server. It is free and has to come with some limitations like cloud save only, no live or database connection. They are widely used by learners, bloggers, and public information related institutes like media, etc. Now moving ahead, we have the Tableau server. So Tableau server is a free server in the internet. This is the YouTube or Blogspot in Tableau data visualization world. It is free and people post their ideas and visualizations here. We call it the visual blog. It has no user management or folder management options. You can hide your work though. It cannot have live data source, but only extract. So many people publish their ideas and custom visualizations here. We can find the inspiration from here. Now next we have the Tableau Online. Tableau Online is a paid server application too, but it is already hosted by Tableau software and so no need to install it on any Windows server. It is better you need the Tableau dashboards to be accessed from anywhere. It has almost all the features of Tableau server but only on the internet, not on your local system. And finally we have the Tableau Reader. So Tableau Reader is a free desktop application which can help us to view the Tableau dashboards created by Tableau Desktop. It supports only extract connection files. It can help new people to try Tableau by getting one license for Tableau Desktop and installing this free software on their end user's machine. It can open the dashboards, interact with them like filtering, tooltip, and parameters. We cannot edit the formula or charts here. Now I hope we have some good understanding of Tableau, its introduction, and the various products of Tableau available for users. Now let's begin with the installation. So the third segment, Tableau installation into your local system. Now here we'll be trying the Windows operating system. Now to install Tableau into your local system, all you have to do is open Google and type in download Tableau Public. And you have the first option that reads download now Tableau Public. I would recommend for beginners to select Tableau Public because it is free. Now let's go back to Google once. Now on my screen we have opened Google. Just now type in download Tableau. So once you type in download Tableau, you can see various options. The first one though is Tableau Desktop, which is a paid version. As I said you have to select Tableau and it is free of cost, and you can try out your sample data over here for free. And once you select the Tableau Public option, you have this particular web page open. And if you go back to the presentation, you can see that I have written something called abc@gmail.com. This is basically your email address for getting registered and downloading the application. So you can write in your email over here, which can be anything like I have written abc@gmail.com. Just make sure that the mail ID you provide is an official one or it is an operational one, as you might have to confirm your download. Once you write in your mail ID, just select the download app option and you can see on the bottom left corner, the application will be getting downloaded. Now I have already downloaded the Tableau Public Desktop exe file into my local system, so I'll just cancel it for now. Now we are back on the presentation mode, and we were in this particular stage where the Tableau public desktop.exe was getting downloaded. Once the file is downloaded, just run the file from your downloads part and you can see this particular screen on your Windows, which will greet you, welcome to Tableau. And here you might have to select I have read and accept all the terms of the license and just install. And there you go, the Tableau Public 2020.4 is installing into your local system, and that's how you install Tableau into your local system. Now we have entered into our next segment where we will be having the Tableau tour. So once you open your Tableau, your screen will be looking something like this. So this is the Tableau in my local system, and you'll be having the screen which is similar to the presentation one. And here you have various options to connect to your data file, which might be an Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, or if you had to download some data directly from the server, you can even do that. So now we'll be working with the local data or the local Excel file in your local system. Just select that Excel file and open it. And there you go, you're on your first worksheet. Just select the Go to Worksheet option and you'll be having your screen redirected directly into the worksheet. And you have the dimensions and measurements on your left corner, and you have the Show Me tab on your right corner, and some marks in here, and filters, pages, and various options on your toolbar. Now we have finished the introductory tour to our Tableau, and we'll understand more about all the options provided in this particular Tableau screen through our worksheets as we start with our first worksheet. So far we have understood what is business intelligence and the Tableau's role in improving your business. Followed by that, we have understood what exactly Tableau is. Then we have understood how to install Tableau into your local system, and we had a brief introduction or brief tour on Tableau. Now we will move ahead and continue with making our own worksheets and the dashboards based on the worksheets we have worked with. So advancing into the fifth part, we will be working with the Tableau worksheets, and followed by the worksheets, we will be working on the sixth part, which is the dashboards. Now without further ado, let's get back to Tableau. So we have successfully booted up our Tableau and we are on the home screen of the Tableau. And on the left bar, you can see that we have various connect options to the Microsoft Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, etc. And if you had to connect to a server, this particular option is not provided in the public Tableau. It might be available in the server Tableau. And you can see that if you had to connect to the server just in case, then you're provided with various options here. Like you can connect with Google Sheets, OData, Web Data Connector, etc. etc. So today we'll be working with local data that is present in my local system. That happens to be an Excel file. So you can see that in my downloads we have a set of Excel files. So we'll be selecting car sales updated data file. Now you can see that the data has been connected to the Tableau and the rows and columns have been presented on the screen. So before getting started with Tableau, let's have a quick update on the data. So many times it happens that you download a data from Google, and sometimes one or the other rows or columns might have some incomplete data. As you can see, there is an incomplete cell over here, which is the curve weight of a particular vehicle that happens to be Cadillac Chevrolet. You can either try to remove this row or you can add some value over here. Like I'm going to add some value. I'm just going to drag this one because they both look a little bit similar. They have a same wheelbase and a kind of same width, so might be the curve weight might match. So we'll just drag it over here, or we'll just write it. Okay, I forgot to enable editing. Fine. So I'll just drag it here and I will have some values. Let's change it a little bit. Okay, so you can see that we have filled up the cell over here. Let's just check if anything else is incomplete. Yeah, there is another one incomplete over here. Let us just add some random values because this is just for practice. Yep, everything else seemed to be fine. So the important point or the update I wanted to give you guys is that when you save this, so when you get into a file and save as, sales updated, so when you save it, make sure that you select the Excel workbook. If you don't select the Excel workbook, you might face some troubles while connecting the data to your Tableau. That was the important update I wanted to give you guys. So just select OK, and your data has been saved now. And let's get back to Tableau. Now let's connect to the data again. By selecting the Connect Data option, you can see the dialog box come up on my screen. So you can just select Microsoft Excel and car sales updated. Open, and you can see the data got connected just now again, and you can see the rows and columns over here. So everything looks fine, and now let's get back to our sheet. So this is the sheet we'll be working on. We'll be creating multiple sheets. So we are creating multiple sheets because we have some options over here. You can see that, right? So this is the sheet, and this is the new sheet option, and this is the new dashboard option, and this is a storyteller option. So basically we'll be working on multiple sheets, and then we'll start a new dashboard, and we will drag all the sheets that we have worked on onto the dashboard so that we can have a view on all the sheets in one single screen. So basically that's what dashboard is. There are multiple operations on dashboard, like connecting to multiple dashboards together and applying some operations like filter, etc. on the dashboards. We will learn more advanced topics on dashboards in the advanced part, which is the next part 2 of the Tableau tutorial. So we'll have a basic understanding of Tableau functions in this particular part 1 right now. No worries on that. So you can see that we have options or the row names written in 2 different colors. You can see that the manufacturer, model, vehicle type, etc. are written in blue, and we can see that there is some sort of ABC text represented on the left side. And similarly on the other half, you can see the curve weight, engine size, fuel capacity, fuel efficiency, horsepower, length, price, etc. And you can see that there is an asterisk written just besides them. So why is this difference? Because Tableau automatically categorizes your data. So it will categorize the data into 2 forms, that is the dimensions and measures. So the dimensions happen to be the unique values of the data, and the values are the numerical values used in your data. So basically the curve weight is a numerical value, engine size is a numerical value, the price, resale values, width, wheelbase, car sales, etc. are the numerical values. And in the dimensions you have manufacturer, model, vehicle type. This happens to be the non-numerical values. So the manufacturer might be Audi, BMW, etc., etc. and the model would be some 320i from BMW, S-Class from Mercedes, etc., etc. and vehicle type might be some just a car or off-roading vehicle, something like that. So these are the non-numerical values. So these are categorized into dimensions. So sometimes there is a chance that you will also find the numerical values in measures. Like just imagine that you are in a college, and the name, address, and your percentage, etc., etc. are your values, and the percentage will be categorized into the numbers, which is the measures. And if you have a student ID which happens to be a number, that will not be in the measures, that will be in the dimensions. But why? Roll number happens to be a numerical value, because the student ID will be considered as a unique value, and Tableau automatically considers it as a dimension. If you want that to be in the measures, no problem in that. You can just drag it down into the measures and it will lie in the measures from dimensions. So that's about the left tabular column where you can see the dimensions and the measures used in your data. And these are the filter options, these are the page options. This is a mark sheet where you can make some modifications onto your chart by making different colors, sizes of the charts, adding text to your results, and adding some details, adding some tooltip. Tooltip is basically something which explains you about the data which you're working with. We'll work on that. We'll see everything in detail, no worries on that. And now coming on to the right side, you can see the Show Me tab, which will help you with the various kinds of charts available that you can work with. So you have text tables, you have heat maps, you can have pie charts, you can have symbol maps, and just maps, pie chart, and side-by-side bar chart, stacked bar chart, horizontal bars, line graph, etc., etc. You can have scatter plots, you can have histogram, you can have box and whisker plots, and many more. Don't worry, you will be working with various types of charts over here. And the best part of Tableau is that if you wanted to use a specific chart, then it will automatically help you with the kind of data you need for that. For example, if you wanted to go with text tables, you can see that it is providing you the prescriptions over here. So it needs one or more dimensions or one or more measures together on the rows and columns in order to use this kind of text table kind of chart to represent your data with. And if you wanted to go with a pie chart, it says you need to have one or more dimensions and one or two measures. That is a must. If you have these kind of data on your rows and columns, only then you can use a pie chart. So this actually helps you out in real time. And now let's get started with our data. Now let's try to identify which is the manufacturer with the highest pricing. Now when you double click on the sheet, you can actually edit it, or you can actually right click on that and just select the rename option, and you can rename it. Now let's select or just write in the highest pricing. Yeah, there you go. Highest pricing is the name of our sheet right now. And now let's grab the manufacturer and drop it down onto the columns. And now let's select the price from the measures and drop it down onto the rows. Yeah, there you go. You can see that we have the data output on our screen. So this particular bar chart helps us identify that Mercedes-Benz has the highest pricing amongst the other manufacturers. Now you can actually make some modifications onto this chart, like you can increase the size of the bars. It is automatically selected over here. You can just scroll it to the right and left by manually, and you can make some changes to the bars. And apart from that, you can even choose an option here which says the sort ascending by sum of price with manufacturer. Basically it sorts it out. So if you select this particular option, you can sort it from the least value to the highest value in the ascending order. And if you choose this one, it will be arranged in the descending order, and you'll get to see the highest one on the left and the lowest one on the right. So this is how it works. And you can see that the first highest pricing manufacturer is the Mercedes-Benz, and the least manufacturing pricing is the Infiniti. And you can see the Beamer over here, the BMW. Personally, I'm a fan of BMW. Okay, now it's just looking, kind of plain without some any additional colors or without a vibrant way of representing your data. I think you know what I mean. So for that, you can just drag the manufacturer onto the color option, and voila, You can see different colors for different manufacturers, and this one basically tells you the highest manufacturer, or this color basically tells you the highest pricing manufacturer, that is the Mercedes-Benz. And yeah, and another option is the chart type. So basically when you chose the manufacturer and the sum of price, the Tableau automatically chose the bar chart. But you can change that. You can just select a line over here, and you can see the complete data has been represented in the form of a line, and you can even select density, and you can select area. So this is how you can change the way you can represent your data. So automatic was the best one over here. So basically the Tableau automatically chose the best way to represent your data, which happened to be the bar chart. You can even select the shape though, and you can make some changes to the shapes. So that's how it is. Now let's get back to automatic again, and it's got the bar chart again. Now let's try to create a new sheet, and this time we'll be working on the horsepower. So which manufacturer offers the highest horsepower? Yeah, so we are on the sheet 2 now. You can see that we have named it to highest horsepower. And yeah, when you come back to this one, you can see the name over here. You can even edit your table by just double clicking on the name, and you can reset some things over here, and that's how it is. And now when we come back to the horsepower, which is the second sheet, I think you remember, right? We are making multiple sheets just so that we can work on our dashboard. So now on the second sheet, we'll be taking up the model name. We are going to identify the car which is having the highest horsepower. Okay, those are a lot of cars. Now just select the sort option, and there you go. We have the Dodge Viper. Yeah, Dodge Viper happens to be a muscle car, and yeah, it should be having the highest horsepower in the manufacturing model, or what do you say it, the basic model without any modifications to it, extra modifications. So the production model of the Viper will be having a 450 brake horsepower. That's really huge. Now we can actually make some modifications. Since we have different manufacturers like Bema, Merck, and any other manufacturers, you can actually categorize the models over here. You just need to drag the manufacturer over here, and you can bring the manufacturer to the first position, and then the model. Okay, another trick I would like to tell you guys is, if you wanted to switch the manufacturer with the model, then all you have to do is just drag the model and place it on the manufacturer. This will automatically switch them. Okay, I didn't place it correctly, I hope. So when you do it, it will actually switch it. Yeah, that's how it's done. So we're going to categorize this models based on the manufacturer now. Let's bring back our manufacturer. Now let's drag it to the second place. And now we have the manufacturer first. So you can see that the data got automatically categorized based on the manufacturer. You can see we have Acura, which happens to be the American version of Honda. So we have Integra, RL, TL, what happens to be the car or model names. So these are the cars offered from Acura with the horsepower 255, or no, it's 225, and 210 and 140. So this is actually the tooltip which is giving you the data according to that bar chart. And now we have the Dodge Viper here with the highest horsepower in the production model. You know, the Dodge and the Ford are
known for their muscle cars with highest horsepower. And here we have the Merck and Mitsubishi, Nissan, and some other Plymouth, Porsche, etc., etc. Now we'll go ahead and create our next worksheet. So let's name it the fuel efficiency. Now let's select the manufacturer and the fuel efficiency on the rows. Now let's select a different type of chart over here. I think you remember the color option. And if you close the show me option, and then you can see the manufacturer over here. Now you can just make some changes for it. You can actually select a manufacturer and you can either keep only or you can remove it. So in Tableau you have the Control Z option, which will undo the changes you have done. You can actually exclude if you want someone to be excluded from the list. So I've excluded Buick. So this was the one we excluded. So that's how you can do it. So when you press on the tool tip, you can see that we'll be having the manufacturer, and followed by manufacturer we'll be having the fuel efficiency provided by that manufacturer. So you can see that we have the good fuel efficiency from Chevrolet and the considerable efficiency from Jaguar. So basically Jaguars are the luxury cars which provide you the maximum comfort and maximum drive feel, so it will actually consume a lot of fuel. Now let's get back and create another sheet, and let's name it as highest resale. Now let's select the highest resale value and model. Now let's arrange it. So according to that, Carrera Cabrio has the highest resale value. That's good. Let's drag the color. There you go. Let's have the manufacturer here so that we can have a good idea of which manufacturer has the highest resale value. So Mercedes has the highest resale value, and also we have the model names over here. We can remove model from marks. This is the reason why we have multiple cars from single manufacturer. So we have all the cars from a single manufacturer. If we remove this model from the marks sheet, you can just see the manufacturer here. Now actually we can make some changes to the sizes. We have the size option in our mark sheet, right? So you can just drag and drop the manufacturer on the size, and then you have various sizes for the various options. And when you come to the rows, you can see that we have the sum of resale values. Basically you can make some changes to it. You can just select measure, and inside measure you have various options of providing average, median, count, minimum, maximum. So let's go with maximum. And now let's try to drag the manufacturer again onto the size, and this time you have the different sizes. So you have Porsche over here, Mercedes-Benz over here. So this is how the categorization takes place. Now let's create a new sheet and understand the filter option. Now just let's name it as filter. And now let's drag the manufacturer. So we have the manufacturer in our columns, and now yeah, we discussed that the highest pricing is from Mercedes, right? So if we wanted to find the next leading one, actually you can see it on the screen, but just imagine that we have a lot of options rather than the few options which are available on the screen. Then what if you wanted to find the second leading highest pricing car? So in that case, you can just make some filters onto it, right? You can add or remove options using filter. So I would like to drag the manufacturer into filter and select all from the list, OK, and apply. Now you can just select the filter, right click it and edit filter, and you can see all the options over here. Just select OK. Now let's right click the manufacturer and select the show filter option so that you can have a filter bar on the right side. So now you can actually remove some options by selecting them. If you just click on the Mercedes-Benz, you can actually see the Mercedes-Benz got removed from the list. So you can see after the Mercedes-Benz, the highest pricing is from Dodge and Lexus. So this is how you can use filters. Let's bring back Mercedes-Benz again. Yeah, there you go. So far we have dealt with the bar charts and the overlapping bar charts, or what do you call it? This is the stack bars, yeah, I forgot. And line graphs. Now we'll deal with the scatter plots and pie charts now. Yeah, so for that, let's create a new worksheet. Let's name it as scatterplot. There you go. Okay, spelling mistake. So when you had to use the scatterplot, the special thing about scatterplot is you need to select both the axes, that is row and column. And when you're selecting the values for rows and columns, you need to select the values from this particular segment, which happens to be the measures. So you'll not be selecting anything from the dimensions. So for now, let's select the engine size for columns and horsepower for rows. So we've selected the engine size for columns and horsepower for rows. So once you have selected the data, you can see a dot over here, which happens to be the engine size for 70 and horsepower 28,000 for 28. This is some random value. Now let's dig a bit more detail into this scatter plot. Now to know the exact details of all the models and all the engine size and horsepower, let's drag the model name into the detail. Now you have some good, a more representable or the more readable form of data. So you can see that we have the highest horsepower engine, that is Dodge Viper, and the engine size is 8 liters and the horsepower offered is 450. Now if you have dragged the manufacturer into the details, then you can see that we have the manufacturer name as well. So the Viper belongs to Dodge, and if you kind of select the manufacturer into shape, then we can actually have different shapes for different manufacturers. So you have the shape option over here. So you can see that we have various shapes for various makers. For example, we have the plus symbol for BMW. So if you can just select keep only BMW, then we have two cars from BMW, which happens to be the model 320i, and the engine size is around 2.8 liters and the horsepower is 193 brake horsepower. And another car we have from BMW is the 323i with the engine size 2.5 and the horsepower 170. Now if you want to bring back all the cars, the simple step is just press Ctrl Z and you have all the cars back in here. And if you want to highlight a specific car, then select the highlighting option. And then let's select Dodge. You can see the Dodge cars got highlighted over here. So just select Dodge Viper, and then we have Dodge Durango. I don't know how to spell that. I'm sorry if it's wrong. And then Dodge Ram Van, and we have the Dodge Intrepid over here. So if we hover onto the highlighted parts, we have the Dodge over there. So that's how you highlight it. Now we have worked on the scatter plot. Now let's create a new sheet and let's work on the pie chart now. I'm just writing pie and it's done. So for a pie chart, you need to select an option and hold Control and select another option together, and then we can do a pie chart. So for that, let's follow the steps. Open Show Me, select pie chart. Okay, I forgot to say, actually we need to select the dimensions first. So let's select something from dimensions. Okay, let's select manufacturer and hold Control, and let's select some value from the measures. So let's select sales. So now open Show Me, and there you go, you have the tab. So I'm in the pie chart in the tab. So we have the pie chart over here. Now I think we can increase the size of the pie chart. So you can just drag it manually, and you can see that the pie chart size is getting increased. So here we have the manufacturer, and it has the sales. Ford has the highest sales, and followed by Ford we have Dodge, and then we have Honda and Chevrolet, Toyota. So far we have understood the types of charts you can make, the types of options that are color, size, label, detail, tooltip, etc, etc, and filters, and the Show Me tab, etc, etc. Now we will move ahead and try to understand hierarchy in Tableau. So let's kind of make a new sheet. Let's rename it as hierarchy. Now we know that the model and manufacturer can be considered as an hierarchy because a model comes under manufacturer. So we can use these two from dimensions and use them as hierarchies. Now let's try to drag model onto manufacturer, and this should automatically show me a dialog box on my screen. Now let's rename it as manufacturer model hierarchy, or just let it be as H so that it's a bit more readable. Now you can see that we have the manufacturer model H hierarchy, and inside that we have the manufacturer and model. Now we can drag the manufacturer model hierarchy onto columns, and we can drag the car sales into rows, and we have the hierarchy values over here. Let's rearrange them. And now if you press the plus option, it's really minor. I don't know how to expand the screen. Let's try Control plus or Shift plus. It's not working. So I think you can see the minute plus option over here. Now let's try to press that plus option, and there you go. You have these sales according to the manufacturer and the models, and that too in hierarchy. Let's remove the car sales and try to put in the horsepower over there. Yeah, you can see the horsepower of each and every car, which is categorized according to the manufacturer. So in Ford we have various types of cars available, and similarly in Toyota, Mercedes-Benz, Chevrolet, Mitsubishi, etc., etc. So that's how the hierarchy works. Now I hope we had a sound understanding of how to create various types of charts, and we have the filter option, scatter plot, pie chart, hierarchy, everything discussed so far. I think you have a brief idea how to work with Tableau. Now let's go through an example of dashboards. Now let's rename this dashboard as car dashboard. Now dashboard is no rocket science. The only thing you do is just select the charts you've worked on and drag them onto your dashboard. That's all. Now let's select the scatter plot and drag it onto the chart. And now let's try to drag the horsepower. And now the fuel efficiency. So you can see the horsepower and fuel efficiency and the highest number of sales and the horsepower compared to engine size all together on one dashboard. So you can see the dashboard name over here, which is a car dashboard. Now you can have some options over here, like you can download the dashboard image and much more. You can even make multiple dashboards just like we made the worksheets, and then you can interconnect the dashboards and you can work multiple operations on multiple dashboards. I hope you had a good understanding of Tableau in Tableau tutorial for beginners. And now let's get back to the presentation. So now we'll discuss the company's hiring and salaries. So there are a lot of companies looking for Tableau experts, and some of the MNC companies which are looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Capgemini, and Wells Fargo. Now let's also discuss the salary for Tableau experts. So the salary for Tableau experts in the United States of America is $81,514 per annum. Now that's an average salary, and these stats are from the Glassdoor. And the highest salary is anything around 110 to 120,000 US dollars per annum. Now let's discuss the average salary of a Tableau expert in India. So the average salary of a Tableau expert in India is anything around 5,06,000 per annum, and the highest salary is anything around 8 lakhs to 10 lakhs per annum. That's for a good experienced employee like 2 to 3 years. And you can also earn more than that. Now these stats are from the Glassdoor website.
Now, without further delay, let's get started with our demonstration on SQL data analysis for today. So we will be having two different Excel files. So one Excel file will be having the customer's data set, and another Excel file will be having the dealership Excel file or dealership data set, right? And along with that, we will get started with the SQL Workbench, MySQL Workbench data tool to run our queries. I hope I made myself clear with that. Now let's get started. Now this is our customer data set. So our customer data set will be having order ID, state where the customer belongs to, and the region of that particular state, and his customer ID and his name, right? Along with that, we have another data set known as dealership data set, right? Remember this order ID, the first column, remember this, right? When we're performing joins, this is the key based on which we are going to perform the joins with two different data sets, right? Now let's check out the second data set. So this is our second data set known as the dealership data. right? So we are having the first order ID, and after that we have order date, delivery days, and dealership name, which particular store is that, and the dealership's PIN code, category of vehicle bought, and product name, quantity, fuel type, traffic, leads, orders, revenue, profit, and basically profit is revenue minus cost to company, right? And the order status, is it in transit, is the order cancelled or placed, or is the order delivered, right? So is it not delivered yet? So these are the order statuses. So we have 4 different of one of them: order in transit, delivered, cancelled, or not delivered. Correct. So these are the 2 datasets that we will be working on today. And let's also take a look on the workbench that we will be executing the queries on. So this is the SQL or MySQL workbench where we will be executing our queries, right? So currently it is using data from a different dataset. So we don't want that. We can create a new prompt and we can get started with our datasets here. So to get started with the new file, we might have to create a new schema first. So let's create a new schema. So you can just write down your name, car dealership, right? So that's the new schema name. Just apply. So you have just created a new schema. Now let's open the schema here, and you have the tables there, and you don't have any data table, right? So for that we might want to add a new table. So double click or right click on that, and here you can see a table, import visit. So browse the path, and here we have the dealership data. Open and click on next. And if you go back here, you have an option called drop data table if the table already exists, right? If you already have a dealership data table there, then you can just drop it off, right? And now let's try to make some changes to it because we don't want the confusion. So either what you can do is you can add an underscore, or if you want to keep the space, or you can eliminate that underscore. I'd prefer to eliminate that underscore and click on next. And there you have the data types, right? So if you want to change some data types, you can do that over here. And I think there is some issue with the first one. Here you have order ID with some extra thing which you don't want here, but we can clear that down the line, not a problem. And import the data file, click on next, and there you go. The data file should be shortly imported. It might take a little while, but it's all right. There you go. Click on next, and 1000 records have been successfully included. Finish. And we want another table also to be included. So what you can do is use the import data wizard once again and browse and import the customer's data this time. Click on next, and the file name, just make sure that you don't have any spaces, but if you literally want the space, use an underscore but not the spacing, right? It might cause some problem while you're writing queries. That's the reason for which we should either eliminate or use an underscore. So go with next, and here we have the same order ID. No worries, we can change the column name over here, right? It's all right. Just import the data, go ahead with it. Click on next and finish. 1000 records have been successfully imported. Now let's run some basic queries like okay, first we might have to use the dataset, right? So we want to use a car dealership. So car dealership, press enter, or you can use control enter. Okay, there was some spelling mistake. So I think we have created the schema with a wrong spelling, but it's okay. All we have to do is just change the name over here, car. So we have added an extra R there, but not a problem. So we are in the schema now. Now let's try to run. Okay, I'll not erase these names because we'll create a document out of it. So we can select any of the tables. Select, let's look at all the columns. Let's look at, okay, double click, start from, yeah, there you go. We have refreshed it. So if you extend, here you can see customer data, right? So let's type in customer data, semicolon, and there you go. When you run it, you have the data, right? So since we have 1000 rows, we can go with the current 1000 rows, or if you want to extend it, we can go with 50,000, or if you want the whole 1 lakh more than, right? There might be data with more than 50,000 rows. In those scenarios, you can also click on the don't limit option. But since we have 1000 rows, we can continue with what we have, 1000 rows, right? Now let's copy and paste the same command and change the name of customer data to dealership. So I'd like to pass a small suggestion here. So when you're writing the queries, use the keywords in caps, right? So uppercase and data tables or column names in lowercase, so that whenever you pass your queries or your document to your fellow developers, then they can easily identify the difference between the keywords and the column names or the data table names. This will help them to resolve an issue if there is, correct? So we have the table over here. Now we have discussed some issue with the column name, right? Now we will proceed with a quick editing query where we will change the column name of this particular dataset, or no, not just the column, correct? Just a moment. So we will take the help of alter keyword. So alter table, and our table name here is customer data. Before that, let's copy this particular keyword here. Or we can do one thing, describe table. We can make use of describe keyword, describe table, customer data, enter. Okay, let's find a way to at least copy that column name. I'm not finding how to copy that. Okay, we found a way. Right click or double click, and we have an option of copy field name. Let's copy the field name, and here let's continue with alter keyword, alter table, customer data, and let's not use the semicolon here. Now use the rename keyword, rename column, paste the okay, order ID. So there's the mistake. So we found a way to copy this column name. Just double click or right click here, copy the field name, so that you get the format or you get the exact data which is written as a column name here. There might be some mistake or there might be some problem during the import, but that's not something to worry about. So we are renaming the column name from the existing name to order ID which we want. So just place it over there, or you can manually write it so that you don't want to take any chances for any more risks. So order ID, there you go. Just run this query. And now let's select the data from customer ID once again. And there you go. You have a proper functional working ID. Now let's rename the order ID column from dealership data as well. So I want to rename customer data to dealership data. Just copy the name of the table and replace it over here. And yeah, let's check the columns first. There you go. You have a similar problem here. So let's change or alter the name of the first column in dealership data as well. Now quickly run the query, and now let's select the data from the dealership data. There you go. So we have a fully functioning or fully corrected data set. So we have order data. Remember, you can see I'm using underscore symbol here whenever or wherever I feel like having the space. You can eliminate the space and keep it as order ID in a continuous form without having a space or without having a underscore. But remember, don't just leave it as a simple space. If you leave it as a space, then you might be having deep trouble while you are writing a query to fetch some data. Okay, so SQL or MySQL Workbench might be confused to have spaces in between the column names or the entity names. Let's not make that happen, right? Now let's continue with some queries. So we are currently in the order or dealership data. So here we have some orders data. So we have a product quantity. Now let's build a a kind of a problem statement where we have to extract a couple of data sets or a couple of results from the data set that we have. Now let's make use of where statement and try to find some answers, right? Now let's say the dealer wants to know one of the dealership names where it is Prime Auto, right? So he wanted to know how many number of orders Prime Auto dealership has received. Now it's a simple where statement. Let's try to answer the query, answer the solution to the problem. Just write down, select what you want to select. I want to select the dealership name, right? Just write down, or let's use the auto suggest mode. So before that, select, leave a space from table name, which is dealership data. Right now you can proceed with the column names. What happens here is when I wrote select from dealership data, it is automatically giving me some recommendations here, right? So the typing time will be less, right? So I want to get back to dealership name, right? Dealership, press tab, and underscore name. I want this dealership name from dealership data, where dealership name is equals to single quote Prime Auto. And I also want to know total number of orders they received. So you can either use count or sum. I'll go with sum of orders. So far so good. So let's run this particular query. Control enter, and there you go. So we have found that Prime Auto dealership has received 5466 number of orders. So if you want to, if you don't want sum of orders here, you can also alias it by typing as total orders received. Yeah. So your column name has been successfully changed, right? And if you don't use alias as, it will still work. There you go. But in case if you want to make the code clearer to your fellow developers, I would recommend to use as, right? Now let's proceed with some other similar where commands so that you have a good habit of how to use where clause in your real-time queries. Now let's go back to our data and see what else we can build as a problem statement. So here we have days to deliver. Now let's say the client wants to know how many cars, if there is a premium, if it's a premium car, then he wants to know the premium cars which took more than 10 days for delivery. Now let's write a where query for that. Place the same query here, and now the name is where auto. I'll use an and statement here. Delivery date or days to deliver is greater than or equal to 10, or we just copy this and paste it over here, and we don't want the alias. There you go. Now let's run this query, and why don't we also write the product name here, right? So we understand which is that car which is taking so much of time. So some of the cars are BMW X3 Baleno. So maybe some reason why these cars are taking a long time for delivery, right? So what happens here is he's able to understand there are couple of cars from couple of categories or couple of manufacturers which are taking a lot of time for delivering the car. So what he can do is he can write down a request or an email to those manufacturers to reduce the time they are taking to manufacture the product so that he can give an early delivery to his clients, right? Now let's run our query back again to see some more places where we can use the where clause. Right now let's see, we want to categorize or we want to find out specific cars from the segment sedan or the category sedan, where the dealership is Elite Automobiles and the fuel type is diesel, right? Let's try to build a where command for that. let's copy the same where clause here, paste it again here, product, dealership name, and instead of days to deliver, let's type category. Instead of prime auto, we will be using elite automobiles. And the category is equals to, since we're using character data type, we will be using single quotes or double quotes. Sedan, control enter, and there you go. So elite automobiles is selecting or he is selling all the sedan class BMW series, and these are the details, right? So if the dealership wanted to know what are the cars or what are the products this particular dealership is selling in category sedan, he wants to know if he's focusing on any other manufacturer or a specific manufacturer, so that he wants to make sure that these type of cars or these type of makers should be proceeding with giving more deliveries of that particular category. Now this is one way of doing it, and now let's identify, since we have a couple of and a few more other categories, we want to find out the total number of orders received based on the category. Let's say the business owner wants to understand which type of category vehicles are being sold a lot, and he wants to make sure that his inventory has good number of such type of vehicles for future deliveries or future orders from the customers. In such situations, you want to group by the category, and group by is also a keyword in MySQL, where you can use that and categorize based on the category provided. Okay, let's build the query so that you can understand it in a better way. So let's copy paste the same query here, and now we will change a few terms here. Instead of product, we will write category, and instead of dealership name, and instead of category here again, okay, we will write down sum of orders from dealership data, group by category, and order by sum of orders descending. Now, what does this query mean? It means I want to find out the category. So SUV category, sedan class category, and hatchback category, right? So I want to find out which type of category is getting the highest number of orders, right? In that case, what happens is, if you find out that SUV category is getting a lot of sales, then what you will do, you will buy a lot of SUV based vehicles from the manufacturers and keep them in your inventory, so that whenever you receive an order for that particular vehicle, you can show the options and make a sale, right? And why are we using order by, right? So we want to find out the highest number of sales, right? Order by descending, what it does is it keeps the highest selling category on top and the lowest selling category on the bottom. So if I run this query, you will understand what exactly I meant. So here you can see SUV category is the one which is receiving the highest number of orders, followed by hatchback, sedan, and multi-purpose vehicle, MPV, right? Now these are the vehicles. So what you will do is, the next business decision what you make is, you will try to order a couple of more SUVs for your inventory, and it can be from different manufacturers, and then you will provide multiple options when a candidate or when a client comes for buying SUV type vehicles. Now to deep dive, let's say, since you've already found out SUV is highest selling, and now you want to find out which is that one single car in SUV category which is getting those many high orders, right? So that you want to make sure that you want to understand this particular car is getting highest number of sales from SUV. So I want to keep a little bigger number of that particular car, so that whenever a client comes for that car, I have it ready, right? So if you make slight modifications to this query, you can come up with that category, and I'll also include product and sum of orders, and order by product, group by product, order by sum of orders descending. Now I am expecting a small error here, but it's all right. There you go. So we might have to place category as well. Okay. Let's try to run this query once again. There you go. So now we also might have to use a where command here, where category is equals to SUV. Now run the query. I guess you will find the answer. There you go. So BMW X3 series is that one SUV which is getting a lot of orders, right? Now if you scroll down, yeah, these are the top five SUV products for which we are receiving total number of highest orders. So what we did here is we are selecting the category column, product column, and total number of orders, right? So we are filtering. Basically, we are using where command to filter down the data. So wherever the category is equals to SUV, filter those data alone. And now we are grouping by the product, which is here. Group by product and category, and order by sum of orders descending. Keep the highest orders on top and the lowest orders on the bottom section where the category is SUV. So in categories SUV, the lowest orders received are 1130 for BMW X5 series. So what you can do is, if you want to cut down, if your inventory is already having a couple of BMW X5 series cars, then what you can do is you can cut down the imports for that category. And if you have less number of X3 series, you can increase a couple of more cars, maybe 5 to 10 more cars, so that you have your inventory ready with X3 series for your clients, right? So this is how you can use where group by order by in your query. So let's say you wanted to eliminate that particular one product manufacturer which is receiving less number of orders in sedan class. So ASC ascending order, and it is sedan. Now if you run the query, you will find out sedan class BMW X3 is the one which is receiving less number of orders in the category sedan, and you can eliminate that. And if you want to specifically identify a particular dealership name which is having lowest sales, then you can also do that, where category is equals to sedan and dealership name underscore name is equals to Elite Motors, Elite Automobiles. You can also include the dealership name in the column here and group by category and dealership name. Sum of orders sum of orders ascending, and run this query, and there is some problem here in the query. Dealership name category error, unknown dealership name in the field list. Okay, so Elite Automobiles. Let's copy this from here. So we might have made a spelling mistake in our query, but not a problem. Just place it here, and there you go. Now we must be getting the answer. Okay, dealership name. Okay, we messed out with the dealership name, so we had a spelling mistake in case of dealership name. Yeah, that's the one. And now let's run the query. There you go. So in Elite Automobiles and Sedan class, we have BMW 5 Series in less number of orders received, right? Now, there might be some reason for it. Maybe the location of the dealership, where it is. So there might be chances, right? So where, let's say you are in South India, or let's say you're in North India, or some part of a country where the roads are really wonderful. You don't have a ghat section. You're not living in Western Ghats, and you're having good longer highways. In those segments of roads, you would prefer sedans. But in case if you are in a ghat section, or if you are in a where we have a lot of mountains, a lot of off-roading trekking kind of regions, in those regions you might prefer SUVs, correct? So there is a chance. Now Elite Motors might be in a place where there are some odd roads, not good roads. They might be a hilly region. It might be a region where you don't have good roads, right? Even if you're not in the Western Ghats or a Ghat region, or even if you're not in a region where you don't have any kind of hillies or mountain regions, but the roads are not good, or if you are passionate about it, it might be a trend, right? It might be some cult if you are coming from a region where there's a good cult for SUVs, right? There might be multiple reasons. So I think that is one of the reasons why there could be a high demand for SUVs or sedans or a specific category of vehicles in a certain region. Now, let's proceed with the next remaining queries or clauses. So far, we have dealt with the with clause, the which, where clause, and order by, group by clauses. Now, let's proceed with case clause, right? Now, case is something like a switch case where you have, if you're familiar with the switch cases in programming, then case is similar to that in SQL. Now, let's say the dealer wants to identify, or the business owner wants to identify different dealership names based on the profit they make, right? Or the number of the revenue they make. And he wants to find out the highest profit making category as high profit, the medium profit, and the low profit. So the threshold is like 1 million. If they're making 1 million, then they are under highest category. If they are making in between 50 to 1 million, they're medium. And if they're making lower than that, then they are least profiting. And if they are least profiting, they might have to, the business owner might have to take some decisions, might be like helping them improve their sales, or fixing their contracts, or if they want to collaborate or combine that particular dealership, the high performing one, right? Some business decisions to make sure that everyone is breaking even in their profits. Now let's use the switch statement here. So as I discussed, high profit. So I'm going to take 2 columns here. So selecting the dealership name, sum of profit they are making, and case starts here. When sum of profit, I'm calculating the profit here, revenue minus the cost to company, is greater than 1 million rupees, that is 10 lakh rupees, then it is considered as high profit. And if the profit is between 50,000 or 5 lakhs or 1 million, then it is moderate profit, else low profit. Now, let's run this query, and we're grouping them by dealership. Let's run this query and see the output. There you go. So we have profit categories. Here we have high profit result. Okay, let's minimize this section here. Yeah, there you go. So there are 5 to 6 dealerships we have across the country, and most of them are in high profit, or all of them are in high profit. So if we increase the number to 10 million, so far we had 1 million. So if it is between 5 million to 10 million, now let's run the query and see if we have any. Yeah, so most of them are making good profits here. There you go. So far so good. Now this is how you can use a switch case statement. Now let's say I also want, okay, let's first use the pattern matching case here, kind of like statement we can use here, like clause. Now I want to make sure to identify a specific product. Okay, let's run this query once again, where we have the dealership data, select all from dealership data. So now we have 8 series, X8 series, right? So some of the premium vehicles. Now I'd like to go with X8, BMW X8. So I want to identify the dealership names which are selling X8 series. Now we can write down the query as select dealership name. What you can do is just copy the dealership name so that we don't make any spelling mistakes. I think we wrote dealership, yeah, we can remove this. Dealership name product from dealership data, where product like, or you can use like, I think we don't need to use equals to there, double quotes, percentage or mod, X8 and percentage. Okay, so what am I specifically mentioning here is, I don't care if it is having anything in front of X8 and after X8. So we are damn sure that the series X8 will be released only by BMW. So in few scenarios, the BMW could be in small cases, or there might be no space in between BMW and X8, right? So I don't want to take a chance. So I want the exact details. So I don't care if there is a space or not, if there is anything else. There might be even spelling mistakes, BM or Beamer X8 or the full form of BMW, right? So, and after X8, I don't want to take any chances here as well. It might be series, it might be cars, right? So I want every detail, the dealership name and the product from the dealership data, who is having X8 car in their inventory. There you go. So we have so many dealerships here. So if I have to take the exact names, or if I don't want any repetitions, then I can go with the distinct here. So distinct of dealership names, where we can find out who is dealing with X8 in their inventory. So we have 5 automakers here, 5 dealerships who are having X8 in their inventory. Now let's also have a count, right? So we can make sure that how many number of X8s they have, count of product. So we can understand how many number of, okay, so there is some query mistake here, aggregated without group by. So here we can add another statement, a group by dealership name or distinct of dealership. I'll just go with dealership name here, and order by count of product is sending. Now let's try to run this query by product. Now let's run the query. There you go. So we have City Motors, who has the highest count of BMW X8 series, and they have the biggest inventory, I presume. So in the next upcoming fiscal year, if there is a requirement of importing X8, then you can check out the numbers, right? If you want to import a huge inventory, or if you want to reduce the number. And you can also, if there is a good sale for Asian dealership for BMW X8 series, you can also improvise their numbers as well. So that's how you can use the pattern matching statement. And if you don't want, if you want to exclude X8, then what you can do is just place an I here, I like, or product not like X8. So if you're filtering out X8 and running numbers or codes for everything every other car but X8, you just want to run that query, and here you can see instead of X8 you can have details repeat, and you can see instead of X8 you have every other detail on every other car. That's how you can go with it. Now let's proceed with joins in our tutorial for today. Now let's create a use case, right? You wanted to identify all the customers who bought an X8, right? So if you check the data, if we go back to our query here and run the dealership query, and you can see here we have order ID, order date, delivery date, everything. But we don't have customer name, but I want the customer name. But customer name is in the table customer data, right? And here we don't have the product detail what they bought, right? So Vivan Sai or Vihan Arab, it can be anyone who got an X5 or X8, right? But now I want to know the exact customers who are or who have already placed an order for X8, or you've already delivered that X8, right? Or let's say you wanted to know if they have placed an order for X8. Now in this situation, you might want to make use of joins, which join two tables and give you the results. So there are basically a couple of joins that you can use: left join, right join, inner join, outer join, Cartesian join, right? So most of the cases you would just go with the keyword join. So it will basically function like a left join, right? You're choosing the first table and you are choosing the matching data from the right table. Now we want the order ID column, we want the customer name, and also the product name, which is equals to X8, and we want to run a join command based on order ID. So order ID happens to be the primary key based on which you can perform the join. So it could be a little complicated orally, so I will write the query so that you have a better understanding for it. So let's quickly run the query. I'm going to use the select statement here, and we wanted the customer name, right? So we want the customer name, or we have it here, right? Double click, copy the field name so that we don't have any mistakes done. And it is from customer data, right? So customer data dot customer name. Okay, let's also copy the customer data table name as well, right? So that we don't have any mistakes in our query. And want dealership data table name as well. So comma dealership data, and what we want from dealership data is product, and we also want dealership data dot order ID, copy the field name, comma from dealership data, join customer data to dealership data on what terms. So order ID is common between customer data and order data, right? So we want order ID equals to order ID, but it will be confusing. So what we can do is join customer data on customer data dot order ID and dealership data dot order ID, right? And we will also use a where clause where product dealership dot product, like again the same statement which is here. There you go. Now we are selecting order ID from dealership data, customer name from customer data, and product name from dealership data from the table dealership data. Join customer data table on customer data dot ID is equals to dealership data dot ID, which is the order ID, where dealership data dot product, right? The product details are in dealership data table, and the product is like anything before X8, anything after X8, because we want the details only for X8, the customers who bought X8. Right, now let's run this query, and there you go. So these are the customers who bought X8s. So we have about 29 results. 29 members are the premium customers who got this premium vehicle X8 series. Now that's how you can use joins in a SQL table, a SQL data query. And so far we have covered joins, we have covered case, we have covered pattern matching, we have covered where clause, group by, order by, and select, and few others. So we have also made a complete documentation out of it. We now know how to create a schema, how to import data, and few protocols to follow when you're importing data, like using an underscore, and we also have covered alter table. If you have some mistakes in your column name, how to alter the name of that column, right? So these are the fundamentals that you can know about SQL, and also some advanced concepts like case and joins that you can know about SQL. So so far we have covered everything that you must know for a beginner, and also we have covered something if you're an advanced level SQL developer. It's like a brushing up tutorial for you, how to use some clauses like group by, order by, and how to use cases, how to use joins, right? Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically there are two different types of data analysis: initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts of what exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliers, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now, let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that, we will project the future, that how they will, improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color. Color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can give the border radius as 20 pixels. And padding to be 16 pixels. Text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python Exploratory Data Analysis, and we will break here for student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have our title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that we might have to install these libraries. So we will be using pip install here, pip install CatBoost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that we will also install LightBGM. Sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, Matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output. And after that we will tell the Jupyter Notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import NumPy as np. Let's quickly copy this and proceed, enter. And now we will be needing Pandas as pd, enter. And now we will be needing Seaborn SNS, and we will also use matplotlib.pyplot as PLT, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import RE from sklearn.impute import simple imputer from sklearn.model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries lit-gbm as lgb from lit-gbm library, import lgbm regressor from catboost, import catboost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here, which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here, which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read CSV, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df.shape, so that you can understand what's happening with this data. right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns. Couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here, and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here, and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. No, 9 would be a little bigger. Now enter. Now we'll use Seaborn library here, SNS dot count plot x is equals to data frame cleaned target. Okay, before cleaned target we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right, null entries, and we also found some. So here we have 299 rows which have missing values, so we will have to remove that. For that we might have to create a new column which has to be named as not assigned, right? Df data frame not assigned, which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df dot df underscore hyphen underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null. So we don't have null values, but we have some illegal entries, maybe some. There you go. Now let's quickly run this query. So there you go. So the new data is about 678,20. So there is some, okay, we did some mistake here. So we are supposed to add it as null NUNL, NULL. Now quickly run this, so we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new dataset. dfna dot describe. So these are the new columns and rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, but by mistake if they added another one, right, triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular dataset. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned dataset. So we can make use of the same code here and paste it right here. And instead of describe, let's write head, so that we have the header of this particular dataset. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous scores. And after that, we will also make use of other columns in this particular dataset, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data, okay? We will categorize the data in terms of, let's say, first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category. If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular dataset, so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it, and now next we will check the data type, column separate and everything, and we will create data type category variables, right? And now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns: our study attendance and previous course. For num call and for cat call, we are considering the other columns apart from the first three, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations. And before that, let's try to add some data from in HTML. Let's try to create a, okay, what we can do is simply copy this particular HTML file here. We can take this and add it here so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data. And we will keep the colors same, dark blue background, and the color for data visualization will be light blue and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with three other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15, 6. Fig size is equals to 15, 6. The same one that we considered before. And we will be using cbon SNS dot count plot, open bracket, this is a function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line, if you need you can add the full stop, if not you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to, so I want lines to be hyphen hyphen, in this way I want the lines, and comma, line width, let's say 0.5 or 0.7, let's go with 0.7, line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done. And we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65, and there is a good number of students which are also scoring above 65 as well, right? So 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document, segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create 3 different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name, length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score. Let's also add single quotes here. Who are scoring in between or less than, let's start with less than or equal to 64. We'll not consider 65, we'll consider 64, divided by len of df cleaned target variable exam score, single quotes, into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, R under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70. Lastly, in between, the ones in between, 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate if possible this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML. Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non na values. We're trying to eliminate na values in place of those values, you can write true. And after that, we will try to eliminate the null. So if it is null, dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance, and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course, and we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure axis equals to ELT dot subplots. So we will be having three different plots here since we're considering three different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot rebel for IDX comma call in enumerate. Call. And we will try to import the Seaborn library here. We will try to create histoplots here, histograms here, histoplot. So line style, we will be selecting this one, and comma. Line width will be 0.7. There you go. Next will be access IDX dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the three ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height and show the plot. There you go. Let's quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these three parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page, and if we run this, it will give you the result. The breaks or gaps in the hours studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is a target variable. Now let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here, but before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation it is the df.corr, which is a data frame, and it is created by selecting only these columns for df cleaned data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the CORR, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df CORR. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level, and extracurricular activities. And we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it.
So welcome to this demo part of this ChatGPT for data analysis. So let's see what are the improvements to data analysis in ChatGPT. Okay, you can interact with tables and charts, and you can add files directly from Google Drive or OneDrive. Okay, so you can upload the latest files version directly from this. You can interact with tables and charts in a new expandable view. You can customize and download charts for the presentation and the documentation, which is very good thing. Okay, data analysis improvements will available in our new flagship models GPT-4o for ChatGPT Plus. If you have ChatGPT Plus, so you can directly use in GPT-4o as well, or teams and enterprise users over the coming weeks. Okay, so basically, what is data analysis? Let me brief you. So data analysis is just a process. It's a tool that empowers organization to make informed decision or predict trends and improve operational efficiency. Okay, so it is the backbone of strategic planning in business, government, and other organization, you can say. Okay, and ChatGPT helps us in reducing time or in finding patterns and trends. Okay, in couple of minutes. Okay, in few seconds, you can say, not even couple of minutes. Okay, so either you can choose data analyst here, or if you have ChatGPT Plus, so you can work on ChatGPT photo directly. Okay, so what do you want? Okay, let's go for ChatGPT 4o only, right? So I have data set, so either you can upload from directly from your computer. Okay, either you can add it from your Google Drive. Okay, if you will add from Google Drive, you have to my Google Drive is connected or not, I don't know. Oh, okay, Netflix. Oh, okay, so it's not connected, my drive is not connected. So first I will try to connect it, or either, okay, leave. What we will do, you can directly add from your Google Drive. Okay, you can see it's showing option. Okay, but I don't have that data in my Google Drive, so I will import from, or you can say upload from directly from this computer. Okay, so first I will write describe the data. Okay, yes, so now it will first analyze it and it will describe the data. Okay, so you can see here the dataset contains information about Netflix shows and movies comprising 12 columns and 8,807 rows. Okay, I downloaded this dataset from the Kaggle. Okay, you guys also can download, or I will provide you in the description box. Right, so we have 12 columns in this: show ID, type, title, director, cast, country, and this is duration, description. Okay, sample data: Dickon Johnson as dead. This is movie USA PG-3, a documentary reflecting on the filmmaker father's life. This. Okay, see, now you will get the options as well. Show data distribution by movie type. Okay, but first what I will do, I will clean this data. Okay, please clean this data. Okay, and would you like to clean that? See, would you like to explore a specific aspect, clean the data, visualize certain trends? Okay, we'll do, don't worry. See, now dataset has been cleaned with the following adjustment: remove duplicates to ensure unique records, handle missing values. Missing values in director, cast, country were filled with unknown, fine. Missing data added, not specified. Rating, not rated. Okay, cool. Okay, updated dataset summary, columns, this. Okay, columns, no change in column, unchanged as no duplicates are found, no critical value. Okay, so now what I will do, please give me 5 different visual charts from the data. Okay, and okay, later on I will tell you one more thing, and you can use this data analyst as well. And I am having this plus version, so I can use ChatGPT 4 directly. Cool, it's analyzing. Yeah, so now you can see, okay, count of movies versus TV shows. See, switch to interactive chart, and this is for, see, here you can download and you can expand the chart. See, okay, and see, this is how you can, predict trends and make charts, different types of charts in few couple of seconds. Okay, and this is legend, I guess. Okay, so this is how, see, second chart, top 10 countries with most content, and this is top 10 directed by number of titles. First one unknown, Rajiv Chilaka, and this content count by rating, this, and this is number of titles added per year. See, how beautiful it is. Okay, so here are the 5 visual charts created from this. Okay, so let's use this. Find popular content by release year, and here if you will click on this view analysis, what you will find this behind, I guess, Python code behind that. See, okay, always show details. I can do this, or either it's okay, you can just copy this code and you can put it in your Python IDE, and you can use this as well. It will show you the exact same graph which ChatGPT created. Okay, see, popular content released by year. Okay, so I want one pie chart based on, let's do country. I need pie chart based on country, or you can make histogram. After this, let's create word cloud. Okay, see, you got distribution of content by top 10 countries. See, which is in 10. Okay, let me do this like this. See, amazing, right? United States 2818, in India 7972, unknown is 831, United Kingdom 419, 245. So how amazing it is. In just few seconds, like 4-5 seconds it took, just 4-5 seconds, and you can expand the view and you can enjoy here as well. See how amazing, right? So this is the power of ChatGPT, you can say. It will, reduce your time to analyze the data. Okay, you can just see the code behind this particular chart, and well, let me please create word cloud using, okay, from this data set. I hope it will create, I guess. One more amazing thing I have, wait, I will show you. See, word cloud, amazing, right? Family, woman, life, take, new, life, love, world, health, team, father. Okay, you can create word cloud based on movie's name. I hope there is column of movie. Oh no, title is there. I guess it will create Christmas black wall people good. Okay, you can change it, no issues. Okay, you can ask show trends of movie genre globally, and now let's see, what if I want all this data into one presentation to present to my colleagues or stakeholders, you can say. So what I will write, please give me all this analysis in the presentation format. Okay, found it very cool. See, this analysis has been compiled in a PowerPoint presentation. You can download link. So this is the download link. So it's downloaded. Let me open this. Let's see how's the PPT. See, amazing. Let's enable editing. See, enable. Amazing, right? See, all the analysis is here. And what you can do is we have the inbuilt designer thing. So you can just click on designer, you can just choose the design how you want. See, or like this, or like this. Let me put like this, okay? And for this, it's generating. Okay, I'm feeling this is good. Okay, for this, let's use this. And for this, let's use this different one. And for this, let's use another different thing. And for this, let's use this one. Okay, so see, your presentation is ready. In just few things, your presentation is ready. So this is how you can use ChatGPT to create presentation as well as the analysis. Okay, in just few minutes you can say. Okay, you just write your prompt here and it will give you the output.
Hello everyone, welcome to Simplilearn's YouTube channel. Today, we'll be diving into some of the most impactful data analytics projects you can work on to boost your skills and supercharge your job search. Why are projects like these so important? Well, here's the thing. In data analytics, employers are not just looking at your qualifications. They want proof that you can solve real-world problems with data. Building a portfolio of hands-on projects shows them you have got the technical skills, creativity, and critical thinking to tackle complex challenges. Each project you work on will not only deepen your understanding of the tools and techniques used in the industry, but also help you master the process of collecting, cleaning, analyzing, and presenting data. So whether you're looking to land that first job or transition into a new role, these projects are exactly what you need to show employers you are ready to make an impact from day one. So let's dive in and see what each project involves and how you can get started.
So the first project that we are going to talk about is the dashboard to find top skills of common roles in data science. So the goal in this project is to create a dashboard that visualizes the top skills needed for popular data science roles like data analyst, data engineer, and machine learning engineer. This dashboard will help users understand which skills are in high demand and how they vary across roles, providing valuable insights for job seekers and recruiters alike. So here are the steps to follow. Step 1. Collect job data. So scrap or collect job postings for common roles in data science from platforms like LinkedIn, Indeed, or Glassdoor. Step number 2 is data cleaning and preprocessing. So you can use Python pandas to remove unnecessary columns, handle missing values, and standardize the format. And then you have to extract the top skills. So parse through the job descriptions to identify key skills mentioned frequently, using libraries like NLTK or Spacey for natural language processing. After that, you have to aggregate skill data by role. So group the data by role, calculating the frequency of each skill for data scientist, data analyst, etc. And then you have to build the dashboard. So you can use Power BI or Tableau to create an interactive dashboard that allows users to filter by role, region, or experience level. And finally, you have to add visuals and interactivity. So design visuals like bar charts, word clouds, and filters to show the top skills for each role clearly. Now in number 2, we have generating sales insights for a customer goods company using SQL. So this project focuses on analyzing sales data for a consumer goods company to derive insights about product performance, customer preferences, and seasonal sales trends. The analysis will provide actionable insights that can drive marketing and inventory decisions. So here are the steps to follow. Step number 1 is to set up the database. So you can load the sales data into a relational database like MySQL or PostgreSQL. Next is data exploration. So use SQL queries to explore the data, getting a sense of available columns, unique values, and any missing data. And the next step is to clean this data. So handle any missing values, duplicates, or inconsistencies in the data by using SQL functions. Now next, you have to write aggregate queries. So you can use SQL aggregate functions to calculate total sales, average order value, and sales by region or category. And then you have to analyze the key metrics. So write specific queries to find insights like top selling products, sales growth over time, and customer demographics. And finally, you have to create a report or dashboard. So you can use a tool like Power BI to visualize and present the insights. Now, the third project that we are talking about is the T20 World Cup Cricket Data Analytics. So in this project, you'll analyze data from the T20 World Cup, such as player performance and team statistics, to understand key factors that contribute to wins. This project is popular in sports analytics and can also include predictive modeling to forecast match outcomes. So the steps are as follows. Number 1, gather cricket data. So use an API like Crick API or a sports data platform to gather match, player, and team data. Then clean the data. Use Python to handle missing values, outliers, and inconsistencies. After that, do feature engineering. So you can create new features like batting averages or bowling economy to enhance your analysis. After that comes the data analysis step. So use Python's pandas and matplotlib to perform exploratory analysis and visualize key metrics like run rate trends, win rates, etc. And then build predictive models. So optionally, you can use machine learning algorithms like logistic regression or decision trees to predict match outcomes. And then you can present findings. So here you have to create visualizations that shows your findings, such as win probabilities or top player performances. Now, next on the list, we have HR analytics to track employee performance. So this project is about analyzing HR data to track employee performance, identifying trends, and giving actionable insights that can improve employee retention and satisfaction. So here are some steps to follow. Number 1 is to collect the HR data. So gather employee performance data such as productivity scores, tenure, attendance, and engagement surveys. After that comes the pre-processing of the data. So use Python to clean the data, handling missing or inconsistent entries. After that, analyze key metrics. So identify patterns and trends such as average performance scores, engagement levels by department, and turnover rates. After that, build visualizations. Use Power BI or Tableau to create interactive visuals, such as line graphs for performance over time or heat maps for engagement scores. After that, identify patterns and trends. So highlight insights like factors affecting performance or engagement to inform HR policies. And finally, create a dashboard for HR managers. So design a dashboard that allows HR to monitor performance metrics and identify improvement areas. Now on number 5, we have real-time share price scraping and analysis. So in this project, you will set up a system to scrap real-time share prices, analyze price trends, and improve visual insights into the market. So here are the steps to follow. Number 1 is set up web scraping. So you can use libraries like Beautiful Soup or Selenium in Python to scrap share prices from a financial website. After that, automate data collection. Schedule the scrapping process with Python's schedule library or a tool like cron to retrieve prices at regular intervals. After that, store the data. Save the scrapped data to a local file like CSV or database for further analysis. After that, analyze the trends. So use Python to calculate metrics like moving averages, volatility, or trading volume. After that, build a real-time dashboard. So use Streamlit or Flask to create a dynamic dashboard that shows real-time data. And finally, you can add notifications. So you can set up alerts or notifications for significant price changes using Python's SMTP library or a messaging service. So now, before moving on to the next project, so without any further delay, let's move on to the 6th project, which is time series analysis with stock price data. So this project focuses on using time series analysis methods to identify patterns and trends in stock price data, helping to forecast future price movements. So here firstly, you will gather historical stock data. So you can use an API like Alpha Vantage or some trusted finance sources to collect daily stock prices. Then comes pre-processing the data. You can clean and format the data for time series analysis. Then explore trends and seasonality. So plot the data and use Python stats models library to decompose it into trend, seasonality, and noise. After that, apply time series models. Use ARIMA, exponential smoothing, or LSTM models to analyze the time series data. After that, evaluate model performance. Measure the accuracy of your model using metrics like RMSE or ME. And finally, visualize forecasts. Plot the forecasted prices and share the findings in report or dashboard. Now on number 7, we have housing price analysis and predictions. So this project involves analyzing factors that influence housing prices and building a predictive model to estimate house prices based on key attributes. So these are the steps to follow. Step number 1 is to gather data. So obtain housing data from sources like Kaggle or Zillow. After that is data cleaning and pre-processing. So handle missing values, encode categorical features, and standardize data. Then comes exploratory data analysis. So use Python's matplotlib and seaborn to identify relationships like square footage versus price, and etc. After that, build a predictive model. So apply a regression model like linear or decision tree regression to predict housing prices. After that, evaluate model performance. So you can use metrics like R squared or mean absolute error to assess accuracy. And after that, present your results. Create visualizations that highlight price trends and predictions across different regions. Now, the eighth project is a market basket analysis. So market basket analysis helps identify products that are frequently purchased together, enabling businesses to make decisions about product placement and promotions. So here you'll first collect transaction data. So use transactional data from a retail dataset, such as those available on Kaggle. Then comes data pre-processing. So clean the data, removing duplicates or irrelevant items. Then apply association rule mining. So use the a priori algorithm with the MLextend library in Python to identify frequent item sets. Then generate rules. So extract association rules with metrics like support, confidence, and lift to measure significance. Then you have to visualize results. So create charts showing high confidence product pairs. And after that, provide business insights. Recommend product placement or promotion strategies based on findings. Now on number 9, we have anomaly detection in time series data. So this project focuses on detecting unusual patterns in time series data, such as fraud in financial transactions or equipment failure in manufacturing. So here are the steps to follow for this project. Number 1 is collect time series data. So obtain time series data relevant to the industry, such as financial or sensor data. After that, pre-process the data. Handle missing values and normalize the data if necessary. Then apply anomaly detection algorithms. So you can use techniques like Z-score, isolation forest, or rolling statistics to detect outliers. And then visualize anomalies. So plot the time series data, highlighting detected anomalies for easier interpretation. And then evaluate accuracy. Test the model on known anomalies to validate its performance. And finally, create a report. So document your findings, including detected anomalies and their potential causes. And finally on the list, we have air quality data analysis and dynamic visualizations. So in this project, you will analyze air quality data over time and create dynamic visualizations that track pollution trends across regions. So here are the steps to follow. Number 1, gather air quality data. So use government data sources or APIs that provide air quality metrics. After that, clean and process data. Standardize units, handle missing data, and aggregate readings by location and time. After that, analyze pollution trends. Calculate averages, trends, and correlations with factors like weather. Then build visualizations. Use Tableau or Power BI to create interactive visuals such as maps showing pollution levels over time. Then create a dashboard. Build a dashboard that updates dynamically with new data. And finally, interpret your results. Provide insights on pollution trends and discuss potential solutions for improving air quality. So that was it, guys. Now you have got some great projects to build your skills and make your portfolio shine. Start exploring, keep practicing, and remember, each project gets you closer to your dream job.
Now, without further delay, let's get started with the top 20 data analytics interview questions and answers. So, as said, we will begin with the theory questions first, and later in the second half of this particular set of interview questions, we will deal with the practical questions. So, the first one in the theory-based interview questions is this one. What is the difference between database and a data warehouse? So, the answer for this question is as follows. A database is an organized collection of structured data used for transactional operations supporting CRUD, which is create, read, update, and delete operations. And on the other hand, a data warehouse is a centralized repository optimized for data analytics processing, aggregating data from multiple sources for reporting and decision making. Now, going into the second question. So these are the typical questions you can expect most frequently. So how do you handle missing values in a dataset? So let me elaborate that a little bit for you. Let's say you have school data for 30 students from a single class. And all of those 30 students will have their roll numbers, names, subjects, marks, etc. Now let's say 1 or 2 of the students out of the 30 students did not attend the semester exams. So they have been marked as absent. Let's say the columns will have float data, and all of a sudden you encounter some data which is alphabetical. Let's say you have marked those students with the letter A to help you recognize that these students were absent. And if you perform some data analytics over that particular data set, let's say this is a sample data set, then you cannot proceed with that particular invalid entry. Let's say instead of adding an alphabetic number, you added something like NA or not present or NP, something like that, which is also not the kind of data you're looking for. And you decide to just leave that data as blank, right? In such scenarios where you have an invalid entry or a value missing or a different data type, that particular situation is called as missing values or invalid data entries. So how do you handle that particular scenario? Now the answer for this question is drop missing values if they are not significant. In particular with Python, you can use dataframe.dropNA function. And if you're going with other models, then impute missing values with mean or median. Let's say you wanted to find out a mean value out of all the entries in the dataset, and you can add that particular mean value or average value in that particular empty cell. Mode for categorical data, forward or backward fill, time series data, and predictive modeling, which is KNN and regression. And lastly, mark them as a separate category used in categorical variables. Now proceeding ahead with the third question, write a SQL query to find the second highest salary from an employee table. Now you don't need an exact data set for this particular one. You don't have to create a table, load the data, and then write a query. You can just write a generic query. Select the column of salary in the dataset name or data table name. You know the aggregate functions like sum, difference, maximum, minimum, right? In this particular case, we wanted second highest salary, so you might have to go with the subqueries here. Now, let's see the query so you can understand better. First, you'll have to encapsulate the maximum salary in a subquery. And out of that subquery, you need to write an external SQL query which looks for the salary number, which is less than the subquery. And you will have to limit that to one row because maybe you'll have 10 entries and you'll just eliminate the maximum. And this particular query will yield you in 9 other rows. You don't want that. You just want one single entry. For that, you just have to add limit 1 so that the output will be generated just for one row. So here is the query. So select maximum of salary and you can alias that column as second highest salary from employees table where salary is less than, and inside the subquery select maximum of salary from employees, and out of that you are limiting the number of rows in the result to 1 so that you will have the maximum but less than 1. And the entries will be only 1 out of the all 10 entries. And there are many other ways to find out the second highest salary. So let's take it as a homework and leave us a comment with your answers. Now proceeding ahead, we have the fourth question. Explain the difference between inner join and a left join. Now the answer for this question is inner join returns only the row where there is a match between both the tables, while left join returns the rows from the left table and unmatched rows from the right table. If there is no match, null values are returned for columns in the right table. Now, this was the difference between both inner and left joins. Proceeding ahead, we have the fifth question, which is the difference between OLTP and OLAP. So firstly, what is OLTP? OLTP stands as an acronym for Online Transactional Processing, and on the other hand, OLAP stands as an acronym for Online Analytical Processing. So the clear differences between both these scenarios is described in the table below. Firstly, the purpose. So we will use OLTP to handle day-to-day transactions, and on the other hand, we will use OLAP for complex analytical queries. Now the second one, operations. So OLTP is regularly used for CRUD operations, which are create, read, update, and delete. And you will be using the insert, update, and delete commands over here. And whereas the OLAP uses aggregate functions and summarizations, which are basically about sum, difference, median, mean, average, average sum, etc. And an example for both of these. So with OLTP, you have banking and e-commerce orders, which you place on online. And for OLAP, you have business intelligence, reporting, day-to-day data analytics, operations, etc. And lastly, data model. So for OLTP, you have normalized data entries, and for OLAP, you have denormalized data entries, faster querying. Now proceeding ahead, we have the sixth question. How do you measure the effectiveness of a marketing campaign? Now, this is a little bit of extended version of data analytics. So here, let's say you're a marketing analyst and you perform some marketing for a month or let's say for a week, and you want to identify the measure of effectiveness of your particular campaign. So for that, what are the formulas that you're going to, follow so that you can absolutely calculate the numbers? Now for that, these are the following formulas you need to apply. Firstly, you need to identify the conversion rate. So conversion rate can be identified by using the total number of conversions divided by total number of visitors to your website into 100, which gives you a percentage or a rate of conversion rate, right? Second one, customer acquisition cost, CAC. So total marketing amount that you had, the budget you spent, divided by total number of customers you approached. That will give you the CAC. Next, return on ad spend. So total revenue that you earned from ads divided by the total cost from the budget you invested to run those ads. Next one is the CTR, number of clicks divided by the impressions into 100 will give you the CTR percentage. And lastly, the engagement rate, which is the overall engagement you received on your website or web page or a post on your social media sites, the total number of likes plus total number of shares plus total number of comments divided by the total number of followers you already have. That gives you the engagement rate. Now, followed by that, we have the seventh question. Can you give me an alternate function to look up? So this is one of the most commonly asked questions in case if the analytics job that you're applying for deals with Excel on a day-to-day basis, right? So whenever you're being asked for this question, give me an alternate to look up, first and foremost, give them one single answer, which is index match. And maybe if someone asks you to mention all the types of lookups, give them H, which is for horizontal lookup, and V lookup, which is vertical lookup, X, which is a combination of both V and H, so X lookup. So there are three types, V lookup, H lookup, and X lookup. And if somebody asks you to give an alternate function for all these lookups, go with index match. So the answer is the alternate function to any of the three lookup functions, which is X, V, and H, is index match function. Now we have the eighth question in the list. What are relationships, joins, and blends in Tableau? So relationship is when you have a data set, let's say you have loaded some sales data on one of the data visualization tools, maybe Power BI or Tableau, then you kind of create a relationship between the data tables, right? You have a sales data. So sales data is not all together in one single data table. So you might be having customer data in a dedicated table, product data in a dedicated table, orders data in a dedicated table, and sales data. You combine all of these based on one single primary key, which might be the order number or customer ID or product ID, and so on. You can establish a relationship between all these tables. So there are types of relations: one-to-one, many-to-one, one-to-many, and many-to-many, 4 different types of relationships. And joins, on the other hand, is something dedicated to the SQL area, where you'll have inner join, outer join, left join, right join, Cartesian joins. There are specific types of table joins there in SQL. Blending is something which is related to Tableau data blending. So one typical answer for all these things is here as follows. Firstly, relationships. Flexible, dynamic links between data tables based on common fields introduced in Tableau 2020.2. Joins combines different tables using data source level, inner, left, right, full join, and Cartesian, right? As mentioned, there are a lot of joins. So before you attend an interview, this is a suggestion. Go through all the joins available in SQL. Let's say you just know 4, but those are not the only 4 are supposed to be present in SQL as per your expectations. There might be a few other. Just explore and learn all the types of joins, and for better, safer side, also have an example in your mind to explain the type of join. And coming back to blends, merges data from different sources. So basically, let's say you had to work on the data and your sources are in 2 or 3 or multiple stages. Let's say part of your data is in PDF format, part of the data is in Excel, part of the data is live stream, part of the data is from website. So data blending, what it does is it combines all the sources that you need to aggregate or segregate your data, pulls the data and combines them into one single table or set, which is possible in Tableau. So that is Tableau data blending. Now proceeding ahead, we have the 9th question. What is DAX in Power BI? How is it different from SQL? So DAX stands as an acronym for Data Analytics Expressions, where EXP is just represented as X here, Data Analytics Expressions in Power BI. And how is it a little bit different from SQL? So the answer for this question, DAX is a formula language used in calculations and aggregations in Power BI. So if you go to the Power BI homepage, let's say you've already loaded the data and you're on the charts page or the visualization page, you get two kind of options in Power BI, measure and quick measure. So whenever you click on the quick measure, then you get some pre-written expressions or pre-written formulas. Let's say you wanted to find out the average of sales and maximum of sales, minimum of sales for a dedicated product. You have readily available quick measures, and if you have some logical or mathematical function which is totally customized by you, then you would choose to write that particular formula using the measure option. So what you're basically doing here is you have an understanding, you kind of establish an understanding between you and Power BI through mathematical language. That exactly is called as DAX. And differences between DAX and SQL is mentioned below. SQL is used for just querying, right? Just write some condition which can be logical or mathematical, and based on the condition you can just extract that particular data or row of data that you're looking for. And DAX, on the other hand, is optimized for data modeling and creating calculated columns of measures. Let's say you wanted to add an extra column. Let's say you wanted to find out the profit, right? You have cost price, you have the selling price, and you wanted to identify the profit. So simple formula, selling price minus cost price gives you the profit. And if you wanted to add that particular column, then you go to DAX and explain this to your Power BI, and it calculates and add that resultant column as an extra column, naming it as profits. So that is what DAX can do. Now proceeding ahead, we have the last question from the theory section. What is the difference between live and extract connections in Tableau? So the answer for this question, live connection connects directly to the database and fetches real-time data, best frequently updated data, but can be slower. Now the second type, extract connection, pulls a snapshot of the data into Tableau's in-memory engine, faster for large datasets, but not for real-time. The second one is maybe considered as a batch processing one, but let's say if you're not quick enough and you try to spend a lot of time on batch processing, just within momentary time periods, maybe like 1 hour or 1 day, the data changes and your report will not stay valid for longer durations. So based on your requirement, you proceed with either live connections or extract connections. Now with that, we have come to an end of this theory part. And after that, let's proceed with the second part. And with the 10th question from the theory part, now we will proceed with the practical part. Now we will continue with the practical questions. And the 11th question in the practical session is as follows. So it's a real-time interview question. And the overall motto of this particular question will be about computing the number of points each team has. So for more details, the description is a little bit too long for this particular real-time question. Let's switch to the MySQL workbench. Now we are on the MySQL workbench, and this is the problem statement. Given a list of matches in a group of stages of Football World Cup, compute the number of points each team currently has, and you're given two tables, teams and matches, with the following structures. Don't worry, I'll explain the tables as well, but before that, let's take a look at the description. Each record in the team table represents single football team. It's like an individual or unique football team. Each record in the matches table represents finished match between two teams. Teams, host team and guest team, are represented by their IDs. So basically, if you're a football fan, there are two basic terms of the teams. If you're playing in the home ground, then you're the host team. And if you're playing in the foreign ground, then you're the guest team. No team plays a match against itself. You need to consider this one. Let's say we are team A. Then team A will not play against team A itself. So you need to be a little more realistic here. That's why a specific point has been mentioned here. And you would like to compute the total number of points each team has scored after all the matches described in the table. The scoring rules are as follows. If a team wins the match, scores strictly more than the goals than the other team. So you should not tie if you are scoring 3, then the opponent team should score less than 3, that is 1 or 2 or 0, so that you can be declared as the winner. If a team draws the match, then it receives 1 point each. And if the match is won by you, then you'll get 3 points. And if you lose a match, then you receive no points. So these are the structures for scores. And after that, the output. This is the expected output. You need to have the team IDs here. These are the team names and these are the points. Now, let's look at the structure. So these are our tables. Firstly, the teams table and the matches table. And these are the columns in teams table. Remember the team ID. Okay. So why to remember it? I'll explain you. So in the matches table, we have the match ID, host team ID, and guest team ID. So host team ID, guest team ID are none other than the team ID. The variable name or the name of the column or the data has been changed here, but nothing different. We'll have the same value here. And these are the values, team ID and team name. And here match ID, host and guest, number of goals, the host card, number of goals, the guest card. Now, according to the consideration of description given, no team is playing against each other. And to win, you should score more than the opposite team. And if you tie, you get 1 point. If you lose, you don't get any point. But if you win, you'll get 3 points. Now, that is a problem statement. Now, proceeding further, let's execute this particular statement to see the data in the teams table. Here we have the team ID, give, never, up, you, gonna, right? And let's also check the matches data table. Match ID, host team points, or host team ID, guest team ID, host team goals, and guest team points. Now, let's process with this particular query. So here we are using a case statement to identify or sum up the goals. Host team points and host team is equals to team ID, right? In the matches table, we gave a different name to that particular entry. So if the host team ID is equals to the team ID from the teams table and host goals are greater than the guest goals, then give the point as 3. And if the guest team is equals to team ID and guest goals are greater than the host goals, then 3. So you have given 2 conditions for both cases, host team and guest team. If team ID is equals to host ID and goals scored by host ID are greater than guest goals, then give them 3 and vice versa. And if host team is equals to team ID and host goals are equal to the guest goals, then you'll get 1 point each. And if guest team is equals to team ID and guest goals are equals to host goals, then 1, right? 2 more scenarios for both host and guest, right? So if you tie, you get 1. If they tie, they get 1, right? And if anything else is happening apart from these 4 scenarios, then you'll get them a 0 in case where you lost the match, right? Firstly, host team goals are greater than guest goals, then host team gets 3. If guest team goals are greater than host team, then guest team gets 3. And if host team ties with guest, then 1, or guest team ties with host, they get 1. And apart from all these scenarios, you just select 0 and you give them, or you give it a summation here, you give it an aggregate function and you count the total number of goals and you'll coalesce this as a subquery and you alias it as num or num points. Now you left join with matches table and after that you group by team ID and you order it by descending. Now let's run this particular query. This particular query will be shared with you for better understanding purposes. Now here we have the output, never gonna give you up. Now with that, let's move to the next question. Next question is based on different data table. We have the Excel data or the sales data here. Retrieve the total sales and profit by category. And for this, let's go back to the MySQL workbench and have a look at the data set and then continue with writing this particular query. Now let's run this particular statement to see our data set. So this is our data set. Row ID, order ID, dates, shipment mode, customer ID, customer name, etc. And the regions north, south, east, west, and central, category, subcategory, product, sales, discount, profit and rate. Everything is here. And according to the question, we need to find out or retrieve the total sales and profit for each category. Now let's go back and run the query. There you go. We are selecting 3 columns here. First column is category. Second column is sales out of all the 4 numbers or 4 columns in the last, which is sales, profit, rate, quantity, etc. And we are aggregating this particular sales inside the aggregate function sum so that we get the total sales, and similarly to the profit as well. And this is from Excel data table. So we are grouping by category and order by sum of sales in descending order so that we can identify which is that one particular category which gave the highest number of sales. So if you run this, you can have the answer right here. So the highest number of sales was given by the technology category, leading after office supplies, and lastly we have furniture. So this is how the sales have been categorized. Let's say you wanted to identify the top one only. In this particular case, you can just limit 1, and if you run it, you'll just have one row here which is technology. Now with that, let's continue with the next question in SQL. Now, the 13th question in SQL is find the top 5 most profitable customers. So the query is a little bit similar to the previous one. The difference is we need to find out the premium customers which give us the maximum sale out of the n number of customers we already have. Now let's proceed back to MySQL Workbench and execute the query for this. Now here we go. We are selecting the customer ID, customer name columns, profit, and we are aliasing it here as total profit. We can rename, let's say you don't want sum of profit as your column header. In that case, you can alias it with the dedicated name you are looking for and use as keyword to rename it from Excel data. And you're grouping by the customer ID and customer name, and we are ordering it based on the alias name here, total profit, in descending order. Just like we did before, we are limiting to only top 5 customers. Just in case if we don't use the limit 5, you'll get all the customers which we have in our dataset in descending order. Since the requirement is only for top 5, we'll go with limit 5. Now let's run this query, and there you go, we have the answer. Customer ID, their names, and the total profit that we earned from their shopping. There you go. Now let's proceed with the next question in SQL. Now the 14th question says count the number of orders per ship mode. So we have a couple of ship modes in our particular dataset, maybe the first class, the regular, the standard, right? So we have wide varieties of shipments offered from our sales data. So now we want to find out which shipment mode has got the highest number of orders so that we can prioritize that kind of or that mode of shipping, right? So let's proceed back to MySQL Workbench and write a query for this particular statement or question. The solution for this particular question is as simple as the question. Just select the shipment mode, and here you need to make sure that the order ID is distinct, because from one particular order ID you can get multiple products. So let's say on one single order ID you might have ordered 100 items, right? And for all those 100 items you might have chosen one shipment mode which is standard. So we don't want that to be happening. So we want just one distinct order ID, and we want the count for that particular order ID. And for that we'll be using the distinct here, and we will alias it as order count from Excel data and group it by shipment mode. And let's say you want to order it by the descending order to find out the highest order count. You can also do it by order by, use the alias name order count here. Done. Let's run the query. Let's first do this. Okay, there has been a small error somewhere. Let's check the columns. Ship mode is what we are looking at. Distinct order ID. Okay, so the thing is we were supposed to take out the underscore here, and fine. Now order by, let's run this. There you go. So same day shipment in descending. There you go. So standard class shipment is the highest one, same day is the last one. So this way you can identify standard class has been the most favorite one for your customers, so you need to more focus on this particular mode of transporting your goods. Now let's go back to the next question in SQL. Now the 15th question for today's session is identify orders with high sales but negative profit. So sometimes you might have sold a particular set of products which are included in maybe like offers, let's say year-end sales, Christmas offer, something like that, just to clear out the inventory. So such type of products might have high sales, but they might have ended up negative profit. So in such situations, we might have to identify those orders. So let's check it out. So there you go. We are on MySQL Workbench right now. And here we have order IDs, customer names, sales, and profit from Excel data. We're using profit because here we want to find out the sales is greater than 500, but profit is less than 0. Negative profit, as well as at least we need a least number of sales, right? So the threshold we are considering here is at least 500. If the sales are better than 500 but profit is negative, then those are the ones we need to identify. Now let's run this query and see the output. There you go. So there are a couple of order IDs and products which were sold out in discount offer, and these are the ones which gave us negative profits. Not bad. And you can also, kind of order it in descending order. Yeah, it's ordered. So you can find out that one particular thing which gave us the maximum number of negative sales. Now let's proceed with the next set of practical questions that you may be asked in your interview. Now let's move ahead with the next part of today's session, which is about some demo based questions and advanced level questions on Microsoft Excel. So explain some product in Excel through an example. Now let's go back to Excel for a live demonstration. Now here we are on Excel. So here you can see IO, item type, and conversions. So we have different number of IOs here, unique IOs. So some are replicated here, and we have about 4 unique item types, and those are also repeated here, and conversions as well. Now I want a pivot table here which gives what type of IO gave me how many number of conversions here. So you can prefer to use a pivot table, but the interviewer wants to understand how good are you with Microsoft Excel. For that, you might want to go ahead with using some product. So here you can see I've already used some product. So, okay, there's a small mistake here. We have to freeze this particular cell. So use F4 to freeze it. And now press enter first and drag the same formula across all the cells so that you can find the output for display sales or conversions for these IOs. Now let's manually write the sum product formula once again. Select the sum product function from here, and array 1 will be this particular one. Close the bracket, equals to, into, write a parenthesis, select this particular array which is the second one, equals to video, equals to video, and freeze it using function F4, and close the parenthesis, star the last column or array which is a conversion. Press enter, yes, and there you go. Now you can drag and drop this particular function across all the rows and you have the number. Now let's take audio and YouTube for your homework. We will share this dataset with you. And now let's move ahead with the next question in Excel. Now the 17th question. What is Anova in Excel? So analysis of variance, also known as Anova, in Excel is a statistical tool that compares the means of groups to determine if there are any significant differences. It's available in Excel with XLS or Excel Stat software. Now proceeding into the 18th question, data filtering. Now this is a little bit simpler version. So for a beginner level demo based question, data filtering can be asked. Now let's go back to Excel and try to perform some data filtering operations in data. So now we are in Microsoft Excel again. So here the question is, based on the data provided below, write a formula or apply filtering to bring the employee names based on the selection in the drop down. Now select the data, apply filter, and let's say I want to proceed with Hyderabad. In the drop down, I'll select Hyderabad. So we have about 3 employees in Hyderabad. You can either do with this way or you can write a filter operation straight away. So proceeding ahead, we have the 19th question, which is about lookup functions in Excel. So we will be having a data set for this as well. Now let's go back to Excel. Now here we have 2 different tables, revenue data and conversion data. Now what I need is, I want the output to be here in I column. I want the conversions for these products. Now you need to perform the lookup operation for this one. We've got two tables, revenue and data conversion, to identify unique key and bring the conversion columns to the revenue table. Now we need to find out that unique column here. So I think line ID could be helpful here. I think this could be a unique ID, what we're looking at. So I'd go with VLOOKUP. Lookup value will be this particular one. Table array, I will go with line item. Yeah, line item. The conversion, right? So I'll give the column number 3 and I want the exact match. Close the parenthesis and there you go. Now you can just drag and drop this particular formula to all the cells and you will have the conversion numbers right in the column I. And in case if you find zeros and you don't want zeros, then you can also add an if else formula here, if 0 or if not greater than 0. Then add, we had some text information, we didn't have any conversions here. So that's homework, or that's a discussion for another day. Now that's a discussion for another day. Let's go back to the last question for today's session. Now the last question for today is create a data visualization using the data table provided. So the data table is on the Microsoft Excel. Let's go back there. So here is the data table that we were talking about. We just need to create a visualization for this. Now that's a really simple one. Just go to insert and here you have recommended charts. Now let's go with the cluster column, or you can also go with this one. So I'll go with this clustered column here and press OK. And you can identify the profits and sales made by each and every employee. And this is the sum of variance. Now with that, let's go back to the...
And with that, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.